But if I'm like, if I would just be sitting here like listening to an audiobook when I go to sleep or something, I wouldn't get it as well as I would if I was driving a car. I don't know why. I still don't think there's a substitute for just sitting there and reading a book. It's like meditating, dude, because you have to clear your mind of everything else and put yourself in the story, dude. Like that's why that's fun. It's meditation for some people. And as I get older, I really like reading. I still like reading. Like I read a lot. I read a lot of things. But I also, for everything that I read, I also watch a lot of like videos on things. Watch a lot of YouTube videos on just how to do whatever, you know? Yeah, it's very strange. Because, yeah, I remember one time Bruno and I were driving down to Intrepid. This was like, I don't know, 2019 or something. And we put on a Malcolm Gladwell audiobook. And I still remember it cold. I forget which book I forget what the name of the book was, but I remember the subject matter. But it was about probabilities in life and, like, social probabilities and stuff. It was pretty cool book. Yeah, Ferg, it's kind of strange. When I'm driving a car, yeah, I'm really susceptible to absorbing information. Like I don't know what the heck that is. That's some missing link stuff, dude. All right, fellas, I'm gonna stop the train here at the smelter junction, and we're gonna save the game, and we'll drive the train back to the depot next time we play Railroads. It's launch time, dudes. Alright. So, launch should be happening here in a moment. So I'm going to switch us over to science and technology, and we will watch ourselves a SpaceX launch. If it goes. The weather might be a little bit of a problem today. The wind is insane this week? Yeah. Your scuba dives have all been canceled. Interesting, course. Yeah. Okay, the SpaceX cast should be going live, like, within the next couple of minutes here, so we'll just chill for a moment. Solution, more boosters. Yeah, Aqua, I got you. Yeah, I know, Orion, the gimbaling is pretty sweet. Bruh. Bruh! I love the science thing. I forgot there was a launch today. Yeah. How is ULA getting engines now? Well, Maverick, the first thing that they do is they go to people that make engines, and then they ask them, can I buy some of those? And then they say yes, and then they get the engines because they exchanged it for money. That's how they buy engines. That's how most companies buy engines that way. Are they reliant on Blue Origin? Yeah, because they gave them money to engine. I don't know. I think I understand what you're asking, but I'm not 100% sure. You're asking, like, how's the engine procurement for ULA going? Yeah, it's fine. Dude, ULA, so Amazon, okay? Amazon, at the 37th Space Symposium a couple weeks ago, announced literally the biggest block buy of rockets ever, in history, ever. They bought 38 Vulcan launches from ULA. 38 Vulcan launches. 15 New Glenn, and then 15 Ariane 6 launches as well. Why did Amazon do this? Amazon did this to launch Project Kuiper, which is Amazon's internet service that's trying to compete with Starlink. 38 Vulcan launches, 15 New Glenn, 15 Ariane 6 or something like that. I think it was 12 and 15. Yeah. That prompted ULA to basically announce a couple of things. One, ULA is looking at reusability. Yep. They put smart reuse back on the table. So Vulcan eventually will be able to jettison its first stage engines, and they'll parachute back down, and they'll be able to recover them with a helicopter. So there's that. ULA also announced that they're building another vehicle integration facility at Slick 41, and they're building another mobile launcher for Slick 41 as well, amongst other things. And another rocket transport ship because of the high bandwidth of launches. But the New Glenn isn't even ready yet. All right. So, did NASA say we're going to the moon before or after the Saturn V was made? Food for thought. You could buy a rocket that hasn't been made yet. That's not ready. In fact, I think that's what they're going to do, Archangel. I think Blue Origin wins in this situation, right? ULA wins a lot. There's like a $10 billion contract or something. But Blue Origin gets to prototype their engines on Vulcan and then use that knowledge on reusing BE4s and apply it to New Glenn. And I also think that Blue Origin is building a reusable upper stage for New Glenn. I think New Glenn is going to try to compete with Starship. I think. And this is inadvertently giving Blue a lot of development money because they're going to build hundreds of BE4s, right? So New Glenn, each New Glenn launch, there's I think they bought like 12. It's like 12 or 15, I forget. So let's just say 10. Let's say they bought 10 New Glenns, right? It's more than that, right? So that's 70. That's 70 BE4s. 38 Vulcan launches. That's, what is that, 76 engines. Blue literally just got, inadvertently with this block buy, has to make about, I'd say give or take about 200 BE4s for testing and for Vulcan and for New Glenn. Like that's 200 rocket engines. That's a lot. So like New Glenn might not be ready yet, but by the time it is, they're going to be really good at making those engines, or at least they better be. 12 New Glenns with an option for 15 more. Holy crap. That's crazy, man. Yeah, it's one of the biggest block buys ever. Ever. This is bigger than the Apollo program in terms of like cost. It's like 60 or 70 rocket launches. It's unbelievable. Yeah. So, you know, people are like, how's ULA with B4 and Blue Origin in the engine? Oh, they're doing just fine. They're doing just fine. People mistook them not talking about this for the longest time as weakness. Don't do that with Amazon. No, that's not a good idea. Yeah. I've been saying this for years, Maverick. Been saying it for years, dude. Don't. Look, just because Blue has nothing to tell you doesn't mean they aren't working on things, guys. Like, that's been the pattern. Everybody says, what is Blue doing? What is Blue doing? They're not doing anything lately. And then Jeff Bezos launched himself on his own rocket into space. And then everybody's like, oh, well, New Shepard's all fine and dandy. Oh, they're just launching Taurus now. What are they doing? What are they doing? New Glenn's never going to happen. What do they do? And then this block buy comes out. And now what people are saying is, oh, it's not going to be ready. There's no way they're going to be ready. They're not going to be ready in time. Like, I don't know how many people, like, there's nothing wrong with being, like, skeptical of big corporations and stuff, but I don't know how many L's these people can take before they figure out that you might not want to underestimate the guy with, like, billions of dollars invested in the space industry. I mean, just putting it out there. Like, just putting it out there. It's a funny thing, you know, funny thing about that. Hide your babos. Tory tweeted today that the engines are arriving mid-year with the first launch at the end of the year. Thomas, I am not worried about Tory Bruno. I'm not worried about ULA. I'm not worried about Blue. They will be 100% fine. Did I miss the Starlink launch? We're getting ready for it right now, Merkers. Launch is teed about 20 minutes from now. Teed up for about 20 minutes. You did it! Congratulations! Amazon's bringing the entire launch market out of a coma. Talk about putting your money where your mouth is.com.
Discovery, go at throttle up.
$10 billion contract. And ULA, it's funny because Tory Bruno has been giving cryptic hints at this over the last couple of years, you know, and nobody picked it up. Not even me. He's been saying for the last couple of years that if the money is there, then they'll do reuse. If the money is there. Let's just say that he may or may not have known that the money was there. Yeah. I saw a post on Facebook that the Kennedy Space Center's missile row would be going back into use. Any idea who's using them? I know, yeah, Archangel, I know who's using every pad. It's all commercial launch providers. Pick a pad, dude. I'll tell you who's using it. Pick one. The only pad that's probably never going to get used again is LC-14. LC-14 is where the Mercury is Mercury Atlas, first Americans in space. It's a historic monument, so they'll probably never use an LC-14 again. But every other pad on missile row is good to go. He also said that ULA would go SSTO if it becomes economically viable. Tory Bruno, please. Tory Bruno, please bring back the X-33, please. He has a lot of R&D money now, Hellfish. I'll believe it when I see it. Yeah. I mean, Forlorn, you can keep doubting, and you can keep taking L's. I mean, that's fine.
Discovery, go at throttle up.
Look, I took the L with the Russian program. I thought Dmitry Rogozin was a lot smarter than he actually is. Yep. Nope. Yep. Wrong. I was very incorrect on that one. Yep. Nope. Yep. Not very smart. Yep. I took the L on that one. Dude, I'll admit it. Yep. I was trying to give the guy the benefit of the doubt for the longest time. No, you're just an idiot. Yep. I'll take the L on that one. That's fine. Did you take the L with a tractor? Yes. Yes, I did. Yeah, I don't know, Beard. I don't know what's going on with that. Whatever happened to Skylon? I don't know. There's a lot of defense money being thrown at it, Sebi, so it probably exists, but I don't know the status. They don't say anything. Yeah, floating. I looked into it, you know. Tried to give the guy a benefit of the doubt because, you know, maybe he wanted to turn over a new leaf. Nope. Hey, sometimes people do. Clearly this was not the case. So, like I said, took the L there, I'll admit it. Yeah, no, you're just an idiot. All right, cool, moving on. That's what I mean. You know, people keep saying that. It's like the people that say, "Oh, Tesla will never scale. Oh, you can't mass produce electric vehicles. Oh, electric vehicles are just a fad." Oh, he did all that? Oh, you're never going to have enough charging stations. Oh, they're working on that? Oh, you'll never be able to scale with demand. That's never good. Oh, they are. Oh. Like, I don't know how many L's somebody can take before they realize that they might be wrong, you know? Like, I'm just putting it out there. I don't think Rogozin's stupid. I think he's just not playing the space program leader game. He's playing to keep your job and your life in the Russian government game. That makes more sense. Yeah, that makes more sense. Yeah, like I said, you know, I thought he would distance himself from this whole thing, but he didn't do that. But it is what it is. Maybe, a lot of people brought up the point. Maybe he had to. I mean, I can understand that. Yeah, that makes sense. I mean, they're not entirely wrong about the scaling with Tesla. We're about to run out of lithium capacity. Yeah, I mean, Elon did say that in the Tesla shareholders meeting yesterday. We listened to that. Mm-hmm. Anyway, we should be getting up to the Starlink mission here in a moment. Ah, here we go. Ooh, new jams. I haven't heard this before. Yeah, Balaxy, I don't think you guys are understanding what benefit of the doubt means, but it's fine. Yeah. I don't, are you familiar with that? Clearly not. Like, I get it. Yeah, I know. I understand. Let's stop talking about that. Screw that. I'm not letting that guy live in my head, you know what I mean? Let's watch a rocket launch. Me too, short line. Fast forward it. Okie dokie. So launch is, we're about 10 minutes out, give or take, from dispose of T0, but the weather might be a little bit weird today.
Nice launch trajectory countdown. Net pad is clear.
10.
See what happens.
9. 8.
Launch auto sequence
7,
has started.
6. 5. 4. 3. 2. 1.
Go for launch.
Yeah, baby.
Vehicle is supersonic.
Stage separation confirmed. Dragon separation confirmed.
Yeah, 12th flight for this booster if they go today, guys.
Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Still nuts that happens, just saying. Hey, Natch.
Thanks for tuning in to the
Kate.
43rd launch of Starlink. Today, we'll be sending another 53 Starlink satellites to low Earth orbit from
Did she
Launch
say
Complex
43rd?
40 at Cape Canaveral Space Force Station
title.
in Florida, just under 7 minutes from now.
I think I have it as
My name is Kate Tice, and I'm a quality engineering manager
Moving over
here
there.
at SpaceX, and I'll be your host for today's
Because you don't want to
mission.
look at
Start of engine chill.
As you may know, Starlink is a constellation of satellites operating in low Earth orbit and provides high-speed, low-latency internet to places all over the globe, particularly in remote areas where connectivity is limited or completely unavailable. Starlink is now live in the Caribbean, which brings us to servicing 33 total global markets.
right by the beach.
If you're interested in seeing
Boy.
all the areas where Starlink service is available, check out our availability map at starlink.com/map, which you see right there. The green shows you where service is available today and where there's a wait list, and the
Stage
gray
1, RP1 load is complete.
Okay.
shows you where service is pending. Today's launch gets us one step closer to adding even more
Service
green
is
to
pending,
that map.
huh? Oh, that's what you
We've
call
got
that.
one of our shorter webcasts today with live coverage ending just after the first stage landing
Right,
and
Nico?
second engine cutoff.
Yeah,
but
here
as
to
always, we
cross-sell.
will confirm deployment of our Starlink satellites
Hey.
via SpaceX's social channels. Now, as
what
most
you
of
gotta
you
do.
are
That's the
aware,
hustle, right?
what makes Falcon 9 really unique is that it's currently the only orbital-class rocket capable of flying over and over again. SpaceX has reflown first
that fairing.
stages since 2017 and fairing halves since 2019. Now, as you can see on your screen there, this rocket
That
has
fair,
soot
dude.
markings on it, indicating that this booster has flown before. Today will mark its 12th flight, having previously launched GPS-33, TurkSat 5A, Transporter 2, and 8 Starlink missions. We'll be attempting to recover this booster again on our drone ship, which you see there, although a little rainy.
That's gnarly, dude.
Just read the instructions.
Toasty!
It's currently parked a couple hundred miles off the coast of Florida in the Atlantic Ocean. Now, the first stage's objective...
Falcon 9 tanks are pressurizing for strong back to retract.
First stage's objective is to accelerate the vehicle through the Earth's atmosphere to space with the help of its 9 Merlin engines, and then separate from the rest of the rocket and return to Earth for landing.
Film cooling the
while the
surface
second
of the
stage
barge
returns
so
to
the
Earth,
rocket doesn't melt it.
While the first stage returns to Earth, the second stage will continue on its journey, lighting its single...
Strong back retract has started.
Correct, Tessa.
All right, so there we heard call out that the strong back retraction has begun. If you watch closely on your screen,
arms are going to
you
open
should be able
up
to
there.
see it there. So the second stage will ignite its single engine, which is optimized for the vacuum of space. The second stage is what will carry the 53 Starlink satellites to their destination in low Earth orbit. Now, speaking of our satellites, they're safely enclosed inside that large barrel structure with the pointed nose at the very top of the rocket. We refer to that as the payload fairing.
No, Mercs.
The job of the fairing is to protect our cargo during ascent until the vehicle is outside the Earth's atmosphere, at which point the fairing separates to expose the satellites to the vacuum of space. Once separated, the fairing halves will fall back to Earth for recovery and future reuse.
I wonder what logo that is.
Now that structure
That's clearly
there
a
that
NASA
you see,
meatball right there.
retracting slightly away from the vehicle, that is
Nope,
the strong
just
back,
plaster
which
over the
is
logo.
part
Put another
of the
one on.
transporter erector, or TE. We use it to roll the rocket out from the hangar to the pad and raise it to its vertical launch position. The TE also routes the vehicle's fluids, powers, and telemetry umbilical from the ground systems to the rocket and satellites until Falcon 9 goes on internal power and clears the pad. So we just saw that strong back open its clamp arms and retract. Now at T0, hydraulics will pull that strong back even further away from Falcon 9.
Stage 1 LOX load is complete.
As it lifts off from the pad. So there we just heard the call out that LOX load is complete on the first stage. LOX load is still undergoing for the second stage. Now, as many of you know, SpaceX and NASA have worked together for many years to put both cargo and people into space. And this week, NASA announced another opportunity for our teams to work together. SpaceX was selected by NASA for the Communications Services Project to demonstrate high-throughput, low-latency data relay services for NASA programs. We'll leverage our technology, such as space lasers, to provide NASA with big improvements in connectivity and throughput for space-based assets. This could in turn help NASA transition from their current in-space communication system, known as TDRS, to a more commercial option, so stay tuned for more on that. So we're just about 2 minutes left to go until liftoff, and Falcon 9 is moving into the final stages of the countdown.
Well, that'd be pretty neat grab, don't you think? Hey, Urban Venture, you're just in time.
Expecting to hear the call for second stage LOX load completion.
Did you talk about the fairings, guys?
At this
Sorry,
point,
someone shot
Falcon
me a
9
message.
is fully loaded with its fuel, which is RP1, or Rocket Propellant 1. First stage is fully loaded.
Stage 2 LOX load is complete.
All right, so first stage is fully loaded, as well as second stage fully loaded with its liquid oxygen. So there we have a shot of the...
Gas closeouts has started.
So there we can see a shot, beautiful view of pad 40. And we can see that white cloud is
on 40,
forming
it throws
around
back
the vehicle.
shot.
That's totally normal. Now that LOX load has completed, the excess liquid oxygen is now venting from the lines that we use to complete that propellant loading.
It's a mismatched set, Tessa. I want to know how many times those
Next
fairing has
milestone
been
is
used.
we'll
There's a
hear
bunch of
that the
logos blanked
vehicle
out
is
on those
in
things.
startup.
There's like clearly a NASA logo that's blanked out, and then there's
Falcon 9 is in startup.
another logo that I don't recognize.
All right, so there's that call.
Look,
at this point,
that's blatantly the
onboard
meatball.
flight computers now have control
What's that
of
one?
the countdown.
Falcon 9 Starlink LD is go for launch.
Launch director says we're go.
All right, and now with that final go for launch from our launch director, at this point in time, the weather
30 seconds.
The weather is looking to cooperate.
Yeah,
the range remains green, ready to support.
Sure.
And the teams are
Why does it
tracking
matter?
no issues. So at this point, all systems are go for launch. Let's watch as Falcon 9 takes our 53 Starlink satellites
15
into
seconds.
orbit.
Okay, here we go.
10, 9, 8,
Should see the sound
7,
suppressors turn on. There they
6,
go.
5, 4, 3, 2, 1.
Hit it.
Ignition and liftoff of Starlink 414.
Okay, here we go. We're flying today. Everything looked good there. 12th flight for this booster.
Vehicle's pitching downrange. MOD chamber pressure is nominal.
And should be going into the clouds here in a second. Boop. Bye-bye.
As you can see on your screen
that's cool.
and heard by the cheers of folks with me here
Look
at
at Shadow of the
Mission
Rocket on the
Control,
clouds.
Falcon 9
See
has
it?
successfully lifted off from the Space Launch Complex
Cool.
40, carrying our 53
That was sick.
Starlink satellites. Although at liftoff, gravity
Power
is
and
pulling
telemetry nominal.
straight down on
That
the
was
rocket.
sick. That was so
As we
cool.
ascend, we actually tilt the engines. The technical term for that is gimbaling for all my rocket nerds out there.
Hi.
And that actually turns the rocket horizontally.
Falcon is supersonic.
I don't know, Flight.
So we're still going up, but with that gimbaling, we're now also heading horizontally away from the launch pad. That's what we call a gravity turn. Now we're going...
Max Q.
There we heard the call out for max Q. That's the point in which the vehicle experiences the greatest dynamic pressure. So we're going to throttle those engines back up.
Yeah, that's pretty crummy weather. Look at all the
And
different
we're
types of
coming
clouds,
up
dudes.
to a series of events that will happen in quick succession. For those of you that have followed our launches previously, you know not to blink. The first of those three events is...
Start of MVAC engine chill.
All right, so we heard call out MVAC
Priming
engine
the
chill.
second
We're
stage
basically
engine.
flowing some of the super chilled liquid oxygen through the turbopumps of the second stage MVAC engine in preparation for its ignition. But first, we have to do MECO, or main engine cutoff. That's where all 9 Merlin engines shut off to slow the vehicle down in preparation for the next milestone, which is stage separation, where the first stage and second stage will separate. As the first stage makes its way back to Earth
They
for
both
landing,
matter,
the second
Doom Guy.
stage continues,
Yeah.
continues its journey with SES-1, or second engine startup. This is where the single Merlin vacuum engine will ignite and
All right.
propel the second stage along with the Starlink satellites to orbit.
Look at how crummy it is in there. Look at all the soot from the second stage engine. Should see a separation here in a moment.
View there inside our inner
Main
stage.
engine cutoff.
There's Miko.
Stage separation confirmed.
Bye-bye. Yeet.
MVAC ignition.
All right, so all 3 of those events in
That's real
quick
good.
succession.
Bearing separation confirmed.
Happy trails, hands.
And there we can see that the fairing
Bye-bye.
halves have separated, exposing our Starlink satellites to the vacuum of space. On the left-hand side of your screen, you can
Look at
see
the
those
fairing.
grid fins deploying on the first stage.
That never gets
Both
old, man.
stages are on nominal trajectories.
Okay, everything looks
All right,
okay
great news
here.
there. Everything looking nominal for both the first
Jack.
and second stage. Now, while the second stage is doing its job, the first stage is actually coming back home to
They
Earth,
will, Archangel,
and
yep.
it will execute 2 burns today. The first burn is the entry burn. We will ignite 3 of its engines, 3 of the 9 Merlin engines at the bottom of the first stage to help slow the stage down.
Oh, it's the IXPE
The
fairing.
second burn is
There
the
you
landing
go.
burn. And that's where we ignite 1 engine, just the center engine, that will bring the vehicle speed down rapidly.
Dude, we're not
in
there
order
yet.
to land on our drone ship. Just read the
We're not up into
instructions.
orbit just yet. She's up in
That drone
space,
ship
but
is
we're not
about
up in
the size
orbit
of a
just
football
yet.
Field.
Discovery.
Bro, naughty.
Everything
Ten
continues
subs.
to look
Thanks,
Acquisition
nominal
man.
signal Bermuda.
for
Appreciate
both
it.
first and second stage. Beautiful shot of the second stage MVAC
Eagles, I
engine
don't care
there
what
on
they
the
say.
right-hand side of your
Say
screen,
whatever they want, man.
with the beautiful blue marble rotating slowly behind it.
This is live, Ving. Yep.
Now that
Yep.
first stage,
Oh,
as
yeah.
you can see, is positioning, beginning to basically float its way back to Earth. It's currently above the Earth's atmosphere. In order to help it make its way back through the Earth's atmosphere, we're going to
How do they calculate the
perform
exact speed
a
of the
re-entry
vacuum in
burn.
space? Acceleration, Rev. Acceleration.
Not currently visible from that view.
I mean, GPS helps
we
too,
have
but acceleration
landing
does
legs
that.
stowed on the side of
That's what
the
internal
booster.
guidance does. When they say vehicles on
Falcon
closed
9
loop
is
guidance,
equipped with 4 landing legs
it's
made
using
of carbon fiber,
the accelerometer
aluminum
to
honeycomb.
figure out where it is
They're placed symmetrically
via acceleration.
at the
'Cause if
base
you
of
have,
the rocket and stowed during.
if you can figure out how fast you accelerate in a given period of time, you can extrapolate your velocity. Simple as that, dude. I mean,
As we come up
it's
to
not that
the
simple, but
entry burn,
that's the general
reminder, this is
idea.
a 3-engine burn meant
It
to
knows
slow
where
the
it is
first
because it
stage
knows
as
where it
hits
isn't.
the
Bingo.
thicker layers of the Earth's atmosphere. As you can see, Falcon 9 has grid fins on it. It's equipped with 4 hypersonic grid fins. They're positioned near the top of the first stage and near the base of the inner stage. So basically where those two pieces of hardware connect. Currently, the first stage is using its grid fins for steering as it makes its
It
return
can
to
use
Earth.
other things, Pete.
Watch
Yeah.
closely, you can see those grid
Page
fins
2
actuate.
trajectory continues to look
So
nominal.
position and time-wise calculation. Yep.
Those grid fins help orient the rocket during re-entry and
not rocket science,
guide the rocket during descent.
It is.
There, we just saw a puff of gas.
I know, bro.
that
Isn't it crazy?
is just nitrogen gas. We use nitrogen gas
nuts, dude.
bursts for attitude
Can't believe
control
that.
on the first stage.
Discovery, go at throttle up.
Hey, Reagan. Long time no see, man. Where have you been?
Stage 1 entry burn startup.
Thanks
So
for the
we can
18
see
months,
the first stage
Stage
has
1 FTS is saved.
begun its
Does it also
entry
navigate
burn.
to the barge on that
We have
principle?
reignited
Or does it
3
use
of the 9
GPS?
Merlin engines.
Supersonic retropropulsion. The engine's slowing itself down, but it's also shooting flames at the plasma. Re-entry heating. The ionized air that turns to plasma during re-entry. Yeah, it fires flames at it to push it away. That's the heat shield. That's my favorite part, and I'm never gonna not say it. So how does Falcon 9 find the drone ship? Well, that's a little bit more straightforward. It's radar. Falcon 9 has a downward-facing radar on it, similar to like how a fighter bomber would have a downward-facing radar. It's looking for the reflective paint on the drone ship. Pretty easy to spot in the ocean, out in the ocean. So, yeah, it's looking for it. The drone ship is in a relative position of where the booster's going to come down, right? But
RP1
you'll see when it locks onto target. The booster will take a
when
huge
the fuel
turn.
burns, it generates soot. Because the reentry occurs
she's
with
coming in
engines
pretty quick
first, the booster actually flies through its own plume,
Yeah, and NASA
which
figured that
deposits
one out,
soot
dude.
on
Yep.
to the side of the rocket. So be
Stage 1
sure,
transonic.
Stage 1 is
be sure to check out the feed from the
transonic,
onboard
meaning it's
camera
going slower than
during
speed of sound.
landing. You may be able to see
Well,
that
some of
soot
it is.
sticking to the lens. When we light the center
It
engine
looks
for
all right
the
floating.
landing burn, we gimbal that engine also to help guide
Oh,
the stage
look
in
at-
addition
oh,
to the
man.
grid fins.
This thing's coming in hot. Look at that grid fin.
There we can see that
That grid fin's
booster
under some heavy load. Look
a
at it shaking around.
Re-entry through
All
the
right.
clouds now.
I think we missed the
Continues
point where it
nominal
locks
with
on.
second
Oh, nope, there it
stage
is.
landing
It found it. It found it.
Stage 2 terminal guidance.
Woo!
Right,
Through
we
the
heard
clouds.
call out, and you can see there on screen the landing burn has begun. Watch closely. We should be able to see the drone ship come into view. This drone ship
Oh!
Stage 1 landing.
Pop the legs.
Deploy.
Stay on target. Stay on target.
As you can see, this booster has
Stage 1
touched
landing
down
confirmed.
once again. This is
What
the
the
12th
frick?
recovery for this particular booster.
Stage 2 FTS is saved.
This recovery also marks the 115th recovery of a first
Man, that
stage
thing came in
booster.
quick.
Gorgeous shot of
115
that booster on our
recoveries?
drone ship. Just read the instructions.
All right. I remember when it was
Up
one.
next will be second engine cutoff,
Second engine cut off.
which we
Expected
saw
loss of
just
signal.
there.
Cape.
Perfect. Should have an AOS through Newfoundland here in a moment. That was sick, dude.
At this
Man,
point
that thing
time,
came in. That
we
thing came in
are
hot.
Waiting to hear confirmation of good orbit
Why can't you land your rocket like
for
this?
our second
I
stage.
can,
Now
Dora.
that the second engine, that
Nominal
Merlin.
parking orbit.
Okay, we have an OI
All
called from the
right,
flight
and
controllers
there's
here.
that confirmation that we were waiting to hear. So with that confirmation of a successful second engine cutoff and good orbit,
Dude.
we'll be ending our webcast for today's
No,
launch.
Kate,
As
don't
I
go.
mentioned previously, we'll be confirming payload deployment via our social channels, so keep an eye out for that. Thank you to the Federal Aviation Administration for supporting our mission. And of course, thank you to our viewers and all our Starlink customers for using our service
Yeah,
at this
Barack.
time. If you're interested in signing up
Acquisition signal near
for
midpoint.
There's your
If you're
AOS.
interested in signing up for Starlink service, head on over to starlink.com.
Fellas, if I was looking at that right, some people said that booster was coming in kind of steep, right? It looks like it was. They may have moved the recovery zone to a place where the waters are a little more calm. Falcon can fly, right? It doesn't have to like come straight down where like on its ballistic trajectory. It can steer a little bit because of the grid fins. Don't think about Falcon 9 like, oh, it can fly to the drone ship. Think about like a guided munition. You have the fins so you can kind of steer it in. You have a nominal area, right, where you can land it. It can go to the left, it could go to the right, just a little bit. I mean, it doesn't have wings, it doesn't fly very well. More like a guided munition, but instead of a kinetic impact, you at the last second it turns the engine on and it just lands. But it's the same idea. It's falling with style, indeed. Does that mean if Buzz Lightyear falls with style? Wait a minute. If Buzz Lightyear falls with style and he's not technically capable of powered flight, but he does have rockets on his back, right? And then fly around on the jetpack, if he falls with style, use rockets to go up and then use wings to come back down. Does that mean Buzz Lightyear is technically a space shuttle? For a brick, he flew pretty good. Yeah, Buzz Lightyear is a space shuttle. All right, cool. Glad that we've established that. Interesting, Sebi. Neat. Yeah, Shimoda. Yeah, it's powered. Yeah. I mean, okay, that makes sense. Yep. It stopped before the legs fully took the weight. I think the burn was a bit early, but I'm not sure. Yeah, Reagan, it looked okay. It looked good enough. I think that the weather was screwing with it. I think they moved the recovery zone a little bit. Did you see how? I mean, look at how steep that thing is coming in. Even right at kind of the last second here, that is a very steep trajectory coming back in. Like, look at the angle of attack here. That thing's really, really pushing downrange as far as it can. I think that they stretched the envelope with this Starlink launch again. We haven't seen a booster come back like that. I mean, look at the angle relative to the clouds. It's steep. That thing is falling with style about as good as a Falcon 9 can. And then at the last second at the clouds, it turns. Woohoo! Right through the clouds. That's cool, man. Yeah, and also the grid fin was going... yeah, that too. I mean, guys, you could see how windy it is. It's super freaking windy. I mean, you see some white caps in the water. When you see white caps like this, little white specks on the water, that means it's a little bit windy. This isn't bad, but it's really easy to see when Falcon 9 comes in that the wind is pushing it around. Look at how much work those grid fins are doing. Yeah, they definitely compacted some crush cores there, Reagan, for sure. But yeah, see the paint? The bullseye is not just there for fun. That's radar reflective material. Falcon 9 has a downward facing radar on it, and it looks for the drone ship. But that's after it does its supersonic retropropulsion. After it does the entry burn, then it looks for it. You can't see it when the rockets are firing, but yeah, that's when it really kind of turns down and starts scanning for the drone ship. And when it finds it, it's really easy to see that it locks on. It'll make a huge change in its trajectory. Lauren, is that Firefly? Yeah, Sammy. Yep. Knew that. Yeah, no, it took a second for it to lock in. It also has a GPS if the radar fails. I mean, yeah, but the primary means of finding the drone ship is radar. It hovered for a second, yeah. I think that's just because of the rough seas. And also, give that booster a break. It's literally done this 12 times now. How heavy is the first stage at landing? I don't know, Julie. 30, 40, 50 tons, something like that. Still heavy. There is a aluminum crush core at the bottom of the landing struts. Oh, and yeah, it definitely crushed them. Yeah. I mean, that's fine. It's okay. There's a sacrificial part right here. Think of it like a one-time use shock absorber, or more like a crumple zone on a car. You know, modern cars are designed to, the engine section is basically designed to crunch so it saves the people inside. There's an aluminum honeycomb, so like an aluminum lattice right here at the end of the legs, and it's called a crush core. And if Falcon 9 does that, if it stops the engine just even a fraction of a second early, or there's rough waters, it'll land and those crush cores will crush, and that energy, the kinetic energy of the booster coming down gets absorbed by the crush core instead of the rocket absorbing it. Because yeah, you don't want this to crumple. That crumpling is just fine, but this part crumpling is no good. You can replace a landing strut. That's no problem. You can replace a landing leg. It's a little bit difficult to replace this part up here, but yeah, it's a crumple zone. They're right there at the base of the landing leg. And I think in this particular scenario, we saw all 4 of them crush. It does happen. It does happen for sure. Watch this. Yeah. Oh yeah. Yep. Yeah, they may have that may have crushed a little bit, man. But it's fine. That's okay. It's supposed to do that. That's why they're there. So if they weren't there, if that crush core wasn't there, the rod would have pushed up and then pushed in on the tank walls of the RP-1 tank for Falcon 9. I'm pretty sure we don't want to push on the fuel tank. That would be bad. Put it at 25 speed? Sure, if you want. It should be able to get it, Bran. Yeah. Maybe they get crushed every time to some degree. I agree. No, Ando, I think they replace them every time. Every rocket is going to crumple at some point. Like I said, that first stage is like 20, 30 tons. I don't know how heavy it is. I forget. I knew that at one point. Let's just say it's heavy. I mean, I can't give you the weight per se, but I can give you the size of this dang thing. Falcon 9 is 150 feet tall. It's a 15-story building. It's 150 feet tall, and I don't know, little under, like maybe 18 or 19 feet wide. It's huge. It's a 15-story building. The thing is gigantic. So it's pretty damn heavy. File this under your watch list. Oh, cool. Yeah, Sup, exactly. It's just a sacrificial part. SpaceX probably has billions of these sitting in a hangar somewhere. What core took the leg and the engine damage a few months back? I'm not sure. I forget, Goalie, I forget. They launched so freaking much, I don't even remember. But Pete, Tactical Pete, if you're still here, you asked in chat, why do they spray the deck of the drone ship? It's to film cool it, so it doesn't burn the metal. So the heat that's being radiated by that rocket engine is, I mean, I don't think I need to say that it's pretty damn hot right in this area right here. Not here or here so much, but right in this area, it's pretty dang hot. And what they do is they spray water down on the drone ship of the deck, and it film cools it. So when the rocket comes down, right, all that heat gets absorbed by the water, and the water, well, it turns to steam. And the water absorbing the heat for heat energy is the same thing as the crush cores absorbing kinetic energy. They turn the water into steam so the drone ship doesn't melt. That's pretty heat. Yep. Yeah, you can tell it's a rocket landing because of the way it is. That's pretty neat. Look at that. That's a Falcon 9. You can tell it's a Falcon 9 because of the way it is. That's pretty neat. Yeah, no, she's good. Everything's all set. That launch looked real good. And yeah, we'll keep an eye on what SpaceX is up to with the tweets there. What in the world is that from? That's from the Nature Walk with Lenny Pepperbottom. Oh, man, classic internet. Yeah, Thomas, I got you. So does the gantry or whatever they use for Falcon 9 have steps, the equivalent of a 15-story building? Well, that's just the first stage, Cantab. Falcon 9 is 220 feet tall with the Dragon or the fairing on the top. 22-story building. That's what the fixed service structure is for. But here, I can show you the scale. It's hard to understand the scale of these rockets, but I'll show you. We'll go to my research folders here. That one shows it pretty well. Note people. People. Yeah, see the people standing around? Yep. It's pretty big. It's pretty big. Yeah, it's pretty big. Stage 2 is now over England. They should have acquisition of signal through Goonhilly. Yeah. And you know what the thing is? Falcon 9 is a small rocket compared to like SLS, it's way smaller. Like, I'm just talking about sheer size, not capability or anything else. Like, don't worry. SLS is like twice as tall as this and like 3 times as wide. It's pretty big. I mean, yeah, there's the trucks for scale right there. You can see a couple of birds right there for your scale. Like, especially the Super Duty. Super Duty is not a small vehicle, and it looks like a freaking toy compared to Falcon 9. Well, Falcon Heavy in that picture, but you get the idea. Yep. She's big. She's a biggin. Yeah, they use the fixed service structure to get up there. They take an elevator, don't worry. He said duty. Yep. Biggins. It's also weird seeing a clean booster. Yep. Yeah. It's a running joke about the undergrad that any large flight of stairs is described as the equivalent to 15 floors, even with quite significant variation in height. Ah, I got you. Has someone photoshopped and modeled an SLS beside a Falcon 9? People have, but yeah. Hang on one second. Give me one moment. Where's that picture? During the AX-1 mission, during the AX-1 mission that launched last week, let me see. There was a picture of SLS and Falcon 9 both on the pad, so it gives you a pretty good comparison. I'm just trying to find the picture. Yeah, maybe it's in my collection here. I'll have to go looking. You found it? Yeah, well this is from Tim. That's not the picture that I'm looking for, but that's from Everyday right there. Yeah, there you go. Yeah, Lunchbox, it's somewhere in there. But yeah, that's more or less right. I mean, you know, you look at some of these big boy rockets, Falcon 9 is actually kind of tiny compared to some of these guys. What's your favorite launch vehicle of all time? It's on the screen. rocket size in perspective. That no, Tessa, we don't use those. Ah, there you go. That's T-Man. That's kind of it. Yeah, that's one of the pictures. But yeah, that doesn't show the scale very well. NASA took a picture from up in a helicopter, looking at both pads. Boone, what's going on? The ISS is a weird launch vehicle. The ISS is not a launch vehicle. There's only one launch... Well, there's actually 3 launch vehicles in this picture, but whatever. This one. My boat. How about this one? That one coming from Emery Kelly. Yeah, that's kind of... It's kind of it. It looks like the double shuttle picture. Here, hold on. There's one of my favorite shots from the shuttle program ever, right here. It's this picture. It's from this angle. Person for scale. Oh, nice, goalie. There you go. You got it? Yeah. See? I like this picture. But I also like that picture, too. But I really like this picture. This picture, this is good. But I like this. You know, Top Gear memes. This is good. But I like this. Twins, man.
Discovery.
Hey, Steiner. What's going on? This is getting out of hand. Now there are 2 of them. Yeah, look at the vehicles in the bottom left corner. That gets you your scale of the shuttle. Shuttle is an absolute chunker. Isn't this scene from Armageddon? Get out. Get out! That's right. That was 2009, Oridon. This is 2022. Nice, Boone. There you go. Yeah, see? See the cars down there? You see how small those things are? The shuttle's beast, man. Big. I mean, you know, the only thing, like, you know what would be really cool? If we had an SLS on one and a shuttle on the other. Like, that would be, I would be okay with that. I think that would be a good idea. It doesn't matter the size of the rocket, it matters how you use it. The only people that say that, Tomas, are people with small rockets. That collect space picture is very good as well. Yeah, see, I like the, yeah, see, that's nice. That's a nice picture. I mean, what? Why are you laughing? I'm right. The only people who say that are people that don't have big rockets. Just saying. People that have very large rockets don't say that. They don't say it's not the size, it's how you use it. No, it's very much the size. A small rocket doesn't go to the moon. It's physics. Why are you booing me? I'm right. Size absolutely matters with rockets, guys. What are you crazy? Girthy SSTO, thank you very much. We are talking about rockets, right? Oh, that's, yeah, direct. I wish, Thomas, I wish. We got any 3D artists in here? Axiom Space is looking for a 3D artist. Is it remote? Ah, yes. Excellent interpersonal skills. Excellent communication skills. Excellent organizational skills. Result-oriented personality with a creative approach to problem solving. So they want you to be able to communicate what you're doing, and they want you to do a good job. Thank you. Thank you. Yes. Is it remote? I'm wondering. It says Houston, Texas. Dang it. I wonder if they do remote. If they do remote, your boy might get a side hustle. You know what I'm saying? Come move in, I got you. What's wrong with Houston? It's not where I live, Warlock. There's nothing wrong with Texas. I like Texas. Actually, check this out. You know, hold on. Look at this. Look at this. Kyle got a picture from the launch. You know what? I like this picture. There's plenty wrong with Houston. I don't live there, so I wouldn't be able to tell you, Karate. But I'll tell you what the problem is. Houston didn't launch 2 shuttles at the same time. Damn straight, man. Always wanted to do that. That is a problem. John got one as well. Let me see. It's funny because John and Kyle were probably like standing right next to each other when they took their pictures. Yeah, it's coming from John Krause. Very good. I think you'll like this shuttle picture. It's not linking me, Nils. It's trying to link me to a Discord. You'll have good food down there, I'll grant you. He posted that before the booster even landed. That's just efficient. Here, let's take a look. I want to look at this Axiom job here. Just real quick. Real quick, and then I'm going to take 5 and jump into KSP. Our team is looking for an energetic and dynamic 3D artist who will primarily be responsible for supporting design efforts, developing visuals, and creating a broad scope of digital assets. A successful individual will have the ability to model and edit 3D assets, render realistic lighting and textures, produce various graphics and animations, and have strong artistic vision. Control F. Remote. Damn it! Oh, shoot. Ah, yes. The 2 to 5 years of experience. Keen sense of aesthetics. Strong presentation skills. Do I have strong presentation skills, chat? You tell me. Just send it. Just gonna send it. It doesn't say it's not remote. Does KSP count as experience? Dude, I'm waiting for the day where I can put some of the stuff that I've made in KSP on a resume. How ridiculous would that? You know what? I'll do it just for fun. I don't care if I get the job. You put Kerbal on a resume? Yeah, I did it just to say that I could. You know? You have 640 references? Oh boy. Send them a link to your channel? Yeah, I'll send them a link to my channel, and the first thing they'll click on is an after hours segment and be like, nope. Just attach your save file. They'd be like, nah, I don't know who this guy is. No. No. Oh my goodness. Yeah, maybe Magellan, yeah, right? Here's the link to that shuttle picture. Yeah, the one with Concorde. Yeah, I like that. Attach Collins' craft file as a bribe. Oh dear. Click my super safe link.zip. Alright. Well, it's 2:30, guys, or 2:25. I don't know, man. I've been out of the job market for like a decade. Like, I don't even know. Like, I'll still apply. I'll see what happens, you know, I guess. Like, but, yeah. I don't know how corporate environments work nowadays, man. I'll be honest with you. I have no idea. To be fair, how many 3D artists will they get who actually fully understand what they're modeling? Yeah. Pretty sure I saw a job listing for working on Factorio where they said you had to attach a save file from the game so they could see how you work. Awesome. That's cool, man. Just figure out your yeah. Okay. Yeah, I guess is that it? Is that all I need to know, Karate? Now, fellas, don't get me wrong. I'm not like not gonna not do it or anything. But I don't really have any updated 3D stuff to show them. That's the thing. Provide a USB drive with all your streams. Yeah, get your BS in mechanical someday and go to a startup. Yep. Actually, Prey, I think I could do well in space operations, to be honest with you. That's the part that I understand really well.
Discovery, go at
I don't think I would need a degree for doing something like that. What's with your ISS model? I didn't make that nearly. That's not my model. It's NASA's. What about your MS Paint material? Now that's something I can link. Yeah, we'd have to make some recent stuff. Karate, I'd be worried though if I was in operations that people would not like me. Yeah. Probably get called a prick good amount of times, dude. Operator here. Check your AOA there, buddy. You're not there to be like, yeah, that's true. That's true. You're there to operate. They might have a bit of too many cooks at the moment, but Railroads Online does have a lot of modeling. Yeah. Model of a paperclip mountain railway. That's right. Smooth operator. Oh, boy. Yeah, boy. All right. What about your models, rocket engines, and fuel tanks? Those are game resolution drifting. They're not high res that they're looking for. They're looking for what's called production models. So production models are usually a lot cleaner and a lot more crisp. You know? Maybe a full send on the back. Nice. Imagine you go Gene from something like that, Lunprod. You have to be. I mean, you have to. Space flight, you can't dick around. Not here, Hellfish. Not here. Yeah, that's true. That's true. Not having to do normal maps in Unreal 5 blows your mind. Yeah. Anyway, do we want to do space news or stuff? Here, let me take that link for Axiom and put it over there.
Discovery.
It's Roger, a 59-month resub. We're old. Nice, Wirelord. There you go. Yeah, Foz. Yeah, that'd be pretty cool. Yeah, I see it. I see it, Thomas. I see it. Here, let's cover this. Hold on. EJ's Space and Rocket Review. Let's see. I want to see this. Here. Look, Eric is covering the Python space zoom call, and it's going pretty well. Okay. Oh. Okay. The hypergulls on the rocket won't explode. Tina's asked if they should be worried that the engine was chugging. Her response essentially was, it's totally fine. Probably. In my response to a question about whether Python Space has a safety officer, Tina points to herself and says, well, that would be me. I mean, guys, somebody erroneously reported that Python was using hypergalls. They aren't using hypergalls. They're using nitric acid, which is different. It's not nearly as toxic as hypergalls are. But also, I mean, nice goalie. Yeah, that they said that everyone's like, oh, they're using hypergalls because the clouds kind of look like hypergalls, so it must be hypergalls. It's nitric acid. Yeah, Tessa, it's not as toxic as hypergalls. Not as toxic. I mean, nitric acid is not good for you. Yeah, Balk, for sure. Like, I mean... Yeah, interesting. Let's keep. I'm gonna read this through again. What did she say? Number 1, they are not employees, but founders, and we are actually shielded by a tall pile of gravel. And let me tell you one thing: that pile of gravel is way bigger than any concrete bunker we've been in yet. The cloud is expected. It's well defined and not even close to the toxicity of MMH and NTO. It's not illegal to develop a rocket engine or even a rocket. Yeah. I mean, guys, I'll say what I said before about Python. Pray, if they want to run their company that way, that's their prerogative. If that's the type of safety culture they want in the workplace, you run your company the way you want. You could just make sure that you do it over there, just like far away from me. Yeah, just. Yeah, you guys can just do that over there and not near me. Yeah, behind, like, not a pile of gravel, but behind like a mountain or something. I don't want to be near you when you do that. What the hell is this? Python micro jump update. After the micro jump of Eiger Stage 1 last month, suddenly Python seems to be on everyone's radar in the US, including Eric Berger, author of Untold Stories of SpaceX, Jordan Noon, the co-founder of Relativity Space, and Jeff Greason, the co-founder of the legendary Rotary Rocket Project, and many others. In true Python spirit is showing things like they are, we had posted a video of the jump, including the scary parts, normally swept under the rug in the aerospace industry. People loved it and we got lots of positive feedback. Until Andrew Rettenmeyer, a propulsion engineer at Blue Origin, raised safety concerns. And then a friend Sent the discussion to Eric Berger, who sent us an email Sunday evening and published a story early Monday within 12 hours, without waiting for a comment. Now Python really got the attention of space communities, so here goes a very quick update on safety procedures, which we will follow up with a Zoom conference next week, April 21st, open to the public. We will introduce Python and host a Q&A. Andrew's concerned was about the orange-red cloud and our proximity to it. It seems that he may have mixed it up with the red cloud created by Blue Origin's lunar lander propellant, MMH and NTO. An extremely toxic combination. Python's green propellant combination of furfuryl alcohol and nitric acid is much kinder to people and the environment, and the major reason for our choice of it. That said, like any toxic smoke, the byproducts of Python propellants should be avoided, and in this case, 3 of Python's key staff founders ran to avoid the cloud. It should be mentioned that the day was still calm. The cloud was very well defined and included a great deal of sand particles. No concrete is laid down to simulate the landing conditions on the Moon or Mars. With regards to our safety procedures, nobody has actually asked us yet what they are. We follow an 8-page checklist from the FAA's launch requirements derived since our time at the DARPA Launch Challenge. This includes large water barrels placed out strategically, including a 325-gallon water truck with a high-pressure hose and various fire extinguishers. All this for a total of 3 gallons of burned propellants. Okay. Not shown in the video, but described in the written debrief attached to the website is that the majority of the staff had left the area to take cover 500 meters away behind a hill. The above-mentioned 3 key people were hiding in a pit behind 10 feet of solid gravel. The 2 of us, Python founders and the authors of this entry, have done 4 unguided expeditions to Everest. 3 unguided and unsupported full-length expeditions to the South and North Poles, and sailed across the Atlantic from Europe to South America. During our expeditions, we lost many friends to the elements. During our expeditions, we lost many friends to the elements, and Python's bird logo, a chew, is to remind us of those brave women and men. This is the only bird that flies high up on Everest, all the way up to the summit. Old mountaineers say they are the souls of dead climbers. We didn't survive all of our expeditions by luck only, but by rigorous risk preparedness. We extend this thinking to Python, and after hundreds of high-pressure water tests, hot firings, and hydrostatic tests, mostly with pressure levels twice that of other small launchers, active or under development, we have yet to encounter one single injury on our team. We build faster and cheaper than any startup in Europe and the US that we know of. Only some of the Chinese startups are on the same level. Our message to the aerospace community is simply this. Should we only allow billionaires and formal aerospace engineers to lead the way into space? Or should we encourage all space enthusiasts cheering on the sidelines that they too can actually start building themselves step by step, even if they are not part of traditional space? Let's think about that for a moment and remember the background of Elon Musk and Peter Beck, by far the two leading stars in space, and none of them are traditional aerospace engineers. Virgin had several accidents, including fatalities. ABL blew up their second stage last month. Astra have been blowing up more rockets than we can count. What puts them and Python apart is neither that we are safer or more unsafe. The difference is that we are more transparent. We hope the community can come to appreciate it and that we can continue to show things the way that they really are in rocketeering. Rocketering? Rocketry is the word you... Okay. Exciting is and sometimes a little bit dangerous. I don't really know what to say. Okay. All right, fellas, part of being a streamer, part of doing a live, and this is not just streaming, this is anybody that does a live cast, anything, like any like live news commentator on the TV or streaming or something, is you kind of have to, you kind of have to think on your feet. You have to be witty. You have to have something to say. That's part of streaming, even if you get a curveball like this. With that being said, I've never been thrown such a curveball that what I'm telling you right now, is the only explanation I have. I have nothing to say. This is just... Yeah. Dude, I could sit here and we could unpack all that, but you know what? I don't want to. I don't want to. How do you feel? Oh, Eric has more follow-up questions. How do you feel about the flack you got on Twitter? It's about time we got some attention. Tom says that Python Space's first launch above the Kármán line will come within the next year. Python Space has been funded to date by Swedish investors. However, Tom says that they're hoping to get some U.S. investors soon. If you want to work for Python Space, they don't have an application. Just send them an email and make it really cool. It's probably safest to work remotely. I dudes, I don't have any words. I'm sorry, I don't know what to say. What do you want me to say? Like, I usually have, you know, a good coordinated response to something like this. I got nothing. This time around. I don't know, drummer. Like, that press statement is quite telling. Give us something. All right, give me a second. I'll try. I'll try. Dude, I don't know what to say. Like, what do you want me to say, dude? I don't know. Like, what do you? I don't know what to tell you. All right, give me a second. Give me a second. All right. All right, so the first thing that my mind is saying with that press statement and what Eric's kind of reporting here, and first of all, yeah, dude, I very rarely agree with Eric on things. I don't hate the guy. I really don't. I don't really like what the kind of stuff that he reports, because I think sometimes it demonstrates a fundamental misunderstanding of how space works, and I can cite a bunch of different examples, but I don't hate the guy. But I think this particular moment he's pretty much spot on. Like, this is what these folks are doing isn't exactly smart. Like, don't get me wrong. Anybody that chooses to throw their hat into the ring of aerospace engineering has my respect. They get at least a little bit of a modicum of respect, right? Meaning, like, you're at, like, your respect level, if you try to do this, goes up to here, right? With that being said, it can go up, Elon Musk, or it can go down. You know, what we have here. Like, it's not easy to make a rocket engine. It really isn't. It's not easy. But something that you really have to do with rockets is and this is very important in demonstrating a fundamental understanding of what you're dealing with. You know how I always talk about how NASA's doing all these tests with SLS, and the wet dress rehearsal keeps going wrong, and they keep finding things that they need to fix. They're doing that in the name of understanding what the heck they made. You're trying to understand what you built. And demonstrating a fundamental understanding of what you made is one of the principal virtues of any type of aerospace engineering, meaning that if you don't understand what you make and you light the match, well, you deserve what's coming. Every aerospace company, right? Every aerospace company, SpaceX, NASA, or aerospace organization, you know, China, even China, Russia, you know, you could go Firefly, you could go relativity, you go Blue Origin, doesn't matter. They all understand this. You have to understand what you're making. And sometimes it doesn't pay off. But to be seemingly that ignorant to the physics here and standing about 10 feet from an untested rocket and lighting it is... And then saying that, you know, oh, we understood what we were doing. We understood. Nobody died. It's fine. It shows a distinct lack of accountability. Like, they said in their press release that, you know, oh, we've been testing it this way for a while and no one's died. That's not how that works at all. And that's what I mean about not understanding what you're making. You're demonstrating a fundamental understanding. And don't get me wrong, I won't miss an opportunity to criticize like Eric Berger or something, but he's 100% right. Like, that's not safe. It's only a matter of time. And you know what? You know how I am. I'm laissez-faire on safety. Like, I really am. Like, sometimes I think that we over-regulate safety and we're too risk-adverse and we don't get stuff done. With that being said, even I, somebody who's like, dude, you got to send it eventually. You can't just sit there analyzing stuff all day. That's not a good idea. Dude, I don't know anything about rockets. Like, really, I really don't. I know about how the theory of how they work. That doesn't mean I won't go make my own rocket engine. You know what I mean? I'll end up losing a hand or killing myself because I don't fully understand what I'm making. Like, heck, it's the case with like a car engine. You know, I've built engines in the past, like a car engine, right? Because I understand it, but even then, I'm very careful, and that's a car engine. That's not nearly as lethal as a rocket engine could potentially be, you know? And that's because I don't really try to mess with things that I don't understand, you know? That usually ends poorly. I said this yesterday, but I'll say it again. John Young, in a press conference right before STS-1, was asked if he, was scared that test, like, are you scared of the test? And he says, they're like, do you understand what you know? Do you understand what you're doing here? How crazy the STS-1 actually is? And he said something, and I'm paraphrasing, but he said something along the lines of, anybody who willingly gets on top of one of the biggest rockets ever made, which is basically just a giant bomb, knowing that they're going to light the bottom and isn't worried, doesn't understand the situation correctly. I mean, John Young said it to a T, 31 years ago. You got to understand what you're making. And you got to understand that a 10-foot pile of dirt 15 feet away from the rocket, or 3-meter pile of dirt that's 5 meters from the rocket is not... That's not being less risk adverse. That's just being stupid. Like, and once again, look, if you want to run your company that way, that's fine. I'm not going to fault somebody for doing that, I suppose. I mean, as long as if you guys know the risks involved, that's fine. But also at the same time, the lack of accountability, basically saying, instead of saying, yeah, you know what, you're probably right, we should work on this. We should work on this. We'll build up more test facilities next time. It shows, like, the lack of taking accountability for your actions is very telling, and that's the biggest thing that I got from this press statement. There is a bunch of false equivalencies in there. We're safe here. We're safe doing task A, so task B, which is a completely different task, because we're safe with task A, we should be safe with task B. That's not how that works at all. And then them citing fuel quantity, like, oh, we only have 3 gallons of fuel aboard our rocket, but we have 300 gallons of water. Well, you're going to combine water with nitric acid, first of all. Like, second of all, naming the gallon naming the quantitative amount of water versus the quantitative amount of fuel that you have and saying that that ratio is somehow a measurement of safety is not very smart. If I have a 1 kilogram ball of uranium and I have 300 gallons of water, that should be able to put the fire out that thing makes, right? No. That is not how that works at all. That's not that. No. Quantities of fuel versus quantities of water are not. That's not the ratio between propellant and suppression is not a figure of safety. That's not how that works. That's not. No, Megas, no last right now. No. I got to pack this up once, or else I'm just gonna get confused again. That's not how that works. You can't use that as a figure of safety. Like, that's the biggest thing, you know? Like, if you made yourself a blockhouse, right? Like October Sky style, you made yourself a concrete blockhouse or something, or even a dirt like bunker, dig a hole in the ground and put like a wood roof over it or something. That would have been better. But the fact that they're just like, oh, let's send about 15 feet from it and send it is super freaking dangerous. That, like, to the point where it's not just being less risk adverse, that's like borderline suicidal. And it demonstrates a fundamental lack of understanding of the physics involved. And once again, I didn't engineer the rocket. I don't know what that thing is. I don't know. And here's the messed up part. Here's the messed up part, guys. If they want to stand that close to that rocket when they fire that engine, that's their prerogative. If they want to, I mean, if you want to do that, that's fine, I suppose. I wouldn't be that close. I mean, I don't. Sile, I think that'll happen. And then to say that this is the last part. Then to say that they're, you know, laissez-faire safety attitude and the spaceflight community basically calling them out on it is somehow gatekeeping space from people is just. All right. Like, that's very odd. And once again, Havix is really stupid. Yeah, once again, fellas, like, dude, if you want to stand that close to your rocket, by all means, go ahead. You know, like, if you want to do that, that's fine. I really don't have a problem with it. Just do it far away from me. Like, if you want to hurt yourself or, you know, if you think that saying, oh, we've killed no one yet, so it's fine, is somehow a figure of safety, then go ahead. Sure, if that's what you think. Man, I hope you have liability insurance at that company, because someone's gonna get hurt. It's only a matter of time. But see, you know, I don't wish any bad juju on these people. I really don't. If that's what you want to do, that's what you want to do. If that's how you think your safety culture at your company should be run, well, go ahead. Stand that close to it. You know, like, the crazy thing about this to me is that all that Python really needed to say is like, yeah, you know what? Yeah, we probably should work on that. We'll work on that next time, guys. Yeah, this, you know, with rocket science, you're so focused on getting the vehicle to work, sometimes you stuff falls to the wind. That's something that we should probably work on, and we will. And, you know, hopefully we come back better with the next test that's much more safe. That's all you have to say. That's literally it. That's it. That's all you have to say. You don't have to say, well, I've hiked up Mount Everest, so I know how safety works. Like, in this day and age, admitting fault is against the rules. I just don't get it. It's a lack of communication and responsibility for me. Even if there was no real danger, you speak to that and maintain professionalism with regards to promoting worker safety. Yeah, Rocket Guy, and that goes back to demonstrating a fundamental misunderstanding of what you're doing. You know, instead of showing the engineering and showing the science behind why this was a safe thing to do, they say, oh, well, we've climbed Mount Everest. What? All right, what does that have to do with this? Oh, well, we've climbed Mount Everest. And yes, some people have died when we've climbed Mount Everest. But that's the namesake for a company, that even though people are going to die, we're still going to push forward. Like, who thought that was a good idea to say that? Like, what? I don't... Yeah, hey, try to keep it classy for me, guys. But Yost, yeah, I saw what you said. Yeah, I agree. But I'm gonna zap you because yeah, try not to swear, you know. Like, but anyway, all right. Now I'm looking at chat. So if people like Megas, you were trying to get me to see last. Just if you could just throw it up again, copy and paste. I'm looking at chat now. As a person about to graduate in chemistry, seeing their nitric acid distillation setup gave me the heebie-jeebies. Yeah, repost. This seems like rich guy sees other rich guys doing rockets and doesn't want to be left out of the rich guy doing rocket stuff club. They tried to insinuate somehow that billionaires are gatekeeping space, which... Alright. And that, you know, formal engineers shouldn't lead the charge, you know, which is... Okay. That... Are you sure you understand what you're doing here? Like, is that their way of saying we're adrenaline junkies who want our lives to be in danger, leave us alone? Cerebral, if that's what they want to do, that's fine. The disciplines, they do not carry over. Indeed, Megas. Yeah, like that's a false equivalency. That doesn't... Infinium Labs. Yeah, oh jeez. Yeah, no, for sure. Sorry, I really didn't realize it was that bad. Yeah, Yost, I try to conduct a teaching environment here, you know, and I don't sometimes I swear too, but even I take the time out. I sit here and stare at the camera awkwardly for like 10 seconds. But yeah, try to keep it clean during the day. With that being said, at night I curse like a sailor. I'm not gonna lie to you. But yeah, you know, are you a safety expert? No, but I stayed at a Holiday Inn. Yeah, it's very, very insane. That's money is gatekeeping space, which is true. So yeah, billionaires have money and are technically gatekeeping space. Not sure there's any other way. I mean, God nukes, I suppose if you want to look at it like that, that's okay. Like, I mean, yeah, that's not wrong. But also, like, every single form of technology was gatekept by rich people, you know? Every single one. Until... You know, they tried to make it more accessible for more people so they could make more money off of it, and then it became available for everybody, like the airplane, for instance, or the train, or the car. You know what I mean? You know, it's only a matter of time before space is accessible for everybody. But trying to insinuate that, you know, like, once again, I'm quoting here. Should we only allow billionaires and formal aerospace engineers to lead our way into space? Or should we encourage all space enthusiasts cheering on the sidelines that they too can actually start building themselves step by step, even if they are not part of traditional space? God nukes. Yeah, interest. Yeah, exactly. All right, we're on the same page there. Here's the thing. Plenty of non-engineers are building their own liquid and solid fuel engines. The difference is that unlike Python, they're trying to understand what they built. Yeah. To use that in a defense to show that they take different risk aversion to testing rockets than most people seems that's a little weird. I mean, another thing that they could have said is just, hey, we think we're fine. This is how we conduct safety, and we're, you know, like, it's our company, you know, and we understand the risks involved, and we're going to go from there. Like, it's, once again, it's a fundamental understanding. That's all that's all you really need to say. They probably wouldn't have gotten the same, probably would have got the same response, but once again, saying like, oh, well, we know we're safe because of this, and we've done this, and hey, what about this? What about, billionaires? Am I right? Like, that's, hey, look, you want to run your company that way, if that's what you want to do, that's up to you, But, man, that, I wouldn't work for you. I wouldn't want to work for you. And I don't think a lot of people would. Yeah, it's very, like, there's a distinct lack of accountability here. And there's a distinct lack of understanding of what you made. And I could be wrong in my analysis. I'd like to talk to these people face to face. Like, if that's what you think, that's fine. But it seems like Eric just did on that Zoom interview. If that's what you want to do, if you understand the risks, go ahead. I just got back from the car show I was on about. Can I post the imager to go through at some point? Sure. I can't do what I want. So, yeah, it's, how about those billionaires? Am I right? Like, okay. It's very strange. It's not. I'd talk to them face to face, not near their rocket, Tessa. But yeah, I mean, yeah, interesting, Sebi. Interesting. But yeah, that's yeah, I'll say what I said before. If that's how you want to do it, go ahead. But I'm not so sure that the engine, that engine was even working correctly. It seemed like that engine was suffering from very bad combustion instability. So it sounded like a pulse jet. It went. Pulse jet, if it's making that noise, that like the buzz bomb noise, right? Like the V1 or, a lot of early cruise missiles did stuff like that too. To my knowledge, that means if you're getting that kind of pulse jet noise, that means you're detonating fuel, which is not what a rocket engine should be doing. Rocket engines that detonate fuel usually break. Yeah. So say that rocket blew up, how bad would it have been? If they had some kind of rapid depressurization of those tanks, Drummer, yeah, they'd be deaf at the very least. All the tests that they have posted vids of show it's always like that. Are they trying to make a pulse jet first stage? I mean, alright, I guess. Except for detonation engines. I mean, if that's what they're trying to do, Tessa, then yeah, but I'm fairly confident that that's not what it's supposed to be doing. Yeah. Yeah, Hater, they did a press interview a second ago, and it's Yeah, see, Forlorn, you're saying, oh, billions for one person is a bad thing. Billionaires are unethical. Yeah, see, Forlorn, you're trying to change the subject to something that you want to talk about that has nothing to do with the initial subject matter. So, please stop. Do better, please. Come on. We're talking about rockets here, okay? You're doing literally exactly what they're doing in that press interview. Don't do that, please. Like, I don't know how many times I need to say this. Like, but yeah, that's what I mean. It's just, it's very strange, man. I don't know if that rocket's supposed to be doing that. Like, there's no accountability here. There's no accountability. There's nothing. Well, that dirt mound is bigger than any concrete bunker we've been in. Size of concrete bunkers don't matter. What matters is that it's made out of concrete. That's very strange. And, you know, like, once again, I'll even go so far as to give them the benefit of the doubt. Maybe they're just nervous because it's a press interview. Sometimes when you're nervous, you say stupid freaking things. Like, I'm not above that myself. But I just don't... There's just a huge lack of accountability here, and that's something that you can't screw around with spaceflight. We were talking about that literally right before we started talking about this. If I was running a spaceflight company myself, I would be a prick. I'd be a huge prick to people because you can't screw around with this stuff. I understand that as much. Like, and I'm not even kidding. Like, I wouldn't be a jerk just to be a jerk. I'd be a jerk because I don't want to see anybody get hurt. You know? Yeah, Penta, we're talking about Python, like Python with an M at the end. They just had a press conference, which is just... Okay. I'm just in the Pangea Aerospace waiting room. Aerospike. Nice, rocket guy. There you go. I don't know, Huzzah. It's very strange, dude. Once again, dude, sometimes when people are put on the spot like that, you say stupid things. Like, you say stuff that you don't mean. And I get that, dude. I get it. But... yeah, I don't know. I just... In this day and age, I'm just super skeptical of people that... And this is just something that I've noticed. Like, in this day and age, I'm just... Anybody that says, well, I know what I'm doing because of this, and the because of this part is something that's completely unrelated, yeah, that's as if there's some kind of uniform measurement of, like, experience that translates between fields of engineering, or, you know, like, risk aversion that transcends different facets of engineering, or different events that you do in your life. Like, what do I always say about quantifying safety like that? That's not how risk assessment works. Risk assessment is based off of source material, right? And you can't compare one risk assessment of how safe it is to jump off a diving board into a pool and then compare that to, like, skydiving out of a plane. Well, you're jumping off something, so they're both the same. They both have the same figure of safety, am I right? No, not at all. That's completely different. That you know, oh, jumping off of a tall diving board at a pool is, you know, that's like 99% safe. So jumping out of a plane is 99% safe too, right? Like that like connection is very, very flimsy. Yeah, it's very weird, man. Very weird. Yeah, it's okay. Hey, yeah, just remind everybody to just keep it classy for me, okay? Starlink has deployed. All right, we got an update from SpaceX on the Starlink 43 launch. Starlink satellites deployed into initial parking orbit. Yeah, baby! Cool. Grissom model rocket clubs. High-powered rocketry clubs are more safe than this. And that is a direct metric that you can compare it to. In fact, the model rocket, high-powered rocketry clubs actually launched something. Where can I find that press thing from Python? Here you go. I linked it in chat, fellas. But yeah, I'm not... Fellas, I decided to do a kind of an extended thing on Python now to kind of collect my thoughts. And kind of go from there. With that being said, I never want to talk about this ever again. Yeah. I never want to say anything about this ever again. I don't think that... Is that rocket orbital? I don't know. Good idea. Can I hold you to it? Well, as the story develops, drummer, we might have to do it some more. But, yeah. I think I've said my piece here. And I'll conclude it in 30 seconds now. If you want to run your company that way, that's fine. But up until this point, they've demonstrated a distinct lack of A, accountability, and B, understanding of what they made. And they've cited several false equivalencies to factors of safety related to rocketry that don't translate between whatever cited source is and safety with rocketry. Just saying you're safe at one thing doesn't mean you're safe at another thing. That's not how this works. And I'm not one to gatekeep space like, you know, they claim everybody else is doing. If you want to run your company that way, that's fine. You just do it far away from me. And that's it. That's it, man. That's it. You do it far away from me, man. Far away. Sorry for linking that at all. Garbage probably doesn't deserve it. Hey, Havocs, it is what it is. People have been asking me about it over the past couple of days. I figure I'd sum it up, and now we don't need to talk about it ever again. Yep. No. Pass this part. And in fact, never do this part again. Let me see, serious. How many cars? Ooh. Now that is lots of cars. Those are nice cars, man. Damn. Jeez. Well, serious, that's more money than I will ever have in all those cars combined. Well, that's pretty neat. Here, look at this car show that Sirius went to. There's some nice cars here. Oh, those are a little rare. Yeah, it's kind of rare. Yeah. Oh. 918. Yeah, that's pretty good. Oh, 3.0 CSL. Very nice. Yummy. Wunderbar. Ist good, yeah. Oh, a 959. Look at that. Damn, dude. These are expensive cars. Whoa. 959. Damn. That's, yeah, okay. I'm not sure what that is, but I'm sure it's a Porsche that I can never afford. Yep, can confirm. Is in fact a Porsche. Looks like a GT3 Porsche. Yeah. I don't know what that is, to be honest with you. It has a shelf on a shelf. Yep. Yep, nope, don't know what that is. I know what that is. Yep. A Ferrari 296 GTB. Not familiar with that. It's nice looking. Looks kind of like a Porsche. Wow. Nice. What is that? Whoa. Okay. What's that doing there? Whoa. Yo. Oh. Oh. Well. Wow. That's Valkyrie right there. That's, Look at the user. Oh my goodness. Oh my god. Oh my god. Hands above the table. You shut up. You shut up. That. Alright. Wow. That's nuts, man. Ah, the Bugatti run. Bugatti. Oh. Ah. Koenigsegg. Very nice. Very nice. Okay. That Koenigsegg is the only one in the world finished in green. Oh, a Chiron. Whoa. Okay, that's expensive. Green inlaid carbon fiber. If you have to ask how much that costs, you can't afford it. Oh, yes. Oh, that's nice. Yeah, Delta HF Integrale. Evoluzione. I like that. I like that more than the Koenigsegg. Not gonna lie to you. You can say that's wrong. Don't at me. I don't care. I'll take this over the other cars. Yeah, that's my favorite car that I've seen thus far. Serious. Dodo-des character. Yep. Group B go brrr. That's right. That's right. That car is sick, dude. I don't think that one's Group B, but yeah, the Delta HF is such a cool car. This is Subaru before Subaru, guys. It's 2.0 turbo all-wheel drive. Screams, man. Oh, a Type 37 Stradale. Type 37. Oh, that car is so sick. Oh, the Type 37. And there's another one over there, Tessa. See the red one? Oh, another car EJ can't fit into. Shut your freaking dirty mouth. Oh, look at the size of the brake rotor, man. Oh, that's sick, man. That's a cool car. Oh, another Type 37. That's nice. Oh, 250. The 1961 Ferrari 250 GTB. It is his love. It is his life. It is his fault he forgot to take the keys. It's nice. That's a nice car. Diablo. Nice. Just run it in reverse to make the odometer go down. Yep. That's how that works, right? Oh, Jag. I'd drive a Jag. E-type race car. This makes me feel things. Jag. You drive a Jag. Nice Ferrari Daytona over there in the background. Tell me you got a picture of the Daytona, man. Damn. I left my wallet in the Jag. That's right. Oh, is this a helicopter air show? There's helicopters back there. Is this... What the hell kind of car show? How much money do these people... Yes, is the answer to that question. Yes. Just transportation for the attendees. Serious, I have a question. Do the types of people that showed up to this talk like this and put random emphasis on different words? Yes, I arrived in my helicopter. It has 4 rotors on it. Yes, I didn't drive my car here. I had servants drive it for me. I don't talk to the help. Do the people talk like that? Yeah, you say no, but also... This is Abe Froman. Alright, the Sausage King of Chicago. It's mostly rich 20-year-olds. Rich 20-year-olds. Alright. Pardon, my friend. Oh, car I can fit into, baby. Shelby GT350. 66 Shelby GT350. And look, there's aero cars back there. What the frick? I'll take that Cobra over there. 427 Cobra. Yeah, the Cobra's nice. I like this one. I can fit in this. I mean, to be fair, I can fit in that one too, but it's for the wrong reasons. Oh, more Enzo pictures. Oh. So, fellas, funny story is, that's not a Shelby Cobra. Nope, not a Shelby Cobra. It's an AC Cobra. Much more rare. Yep, much more rare. Yeah, oh yeah. See the AC logo on the hood? Much more rare. Yeah. Yeah. That AC was the company that made the chassis, and they put a Ford motor in it. And then Shelby made a variant of an AC Cobra called the Shelby Cobra. That's the one you see the most. The AC Cobras are the original run. Those are extremely freaking rare. Those are, if you have the AC, that's that car right there. If it's an AC Cobra with a 427 side oiler and matching numbers, that car is, yeah, $1 million. Yep, I know. Bugatti, more Koenigsegg. Ah, yes, the Tempesta. Nice. I think my favorite car out of all of them is either this one or the Delta. Yep. To be 100% honest with you guys, like, I appreciate super and hyper cars. I really do. They don't do anything for me. The Enzo is cool. Don't get me wrong. That does nothing for me. Nothing. That's cool. That's really cool. That does something, absolutely. Diablo's cool. 250 is cool. Type 37 is cool. Delta HF is one of my favorites. That does nothing for me. And I'm not hating on Koenigsegg by any means. It's just, alright. Yeah. That's cool. I appreciate it. Yeah, so don't need that. I mean, it's nice. Don't get me wrong. If somebody offered me one, I'd take it. Like, but yeah. There is one car though. If somebody offered me, I'd say no. Because if somebody offered me that, I would be too afraid to drive it. Because there's like 4 of those or something that exists. I would. Yep. Nope. No. Yeah. No. I'm not worthy of that. I'm not worthy. It's like Wayne's World. We're not worthy. We're not worthy. We're scum. We suck. Like, that's... Yep, nope. Sell it and buy 500 F-150s, yep. So you like this too? Yes, Manta. Manta 400. Quick Nils, look, just because I'm American doesn't mean that I don't know my European cars. I know my European cars. Yeah, Manta. We didn't get those over here. I'd wreck it, no problem. Serious, what is this? What are we looking at here? No. This is a nice 67. Very clean 67. Somebody put a lot of time into this. See how the paint looks like you're looking in a mirror? Yeah. Yeah, that's how you know the car is expensive. Yeah. Oh. I don't mind this. I know that's cool. I dig it. I think that's neat. Dude, look. Look at the oh man. That's an Ascona 400, not a Manta. Are you sure? Angry Sec, it looked like a Manta. I only looked at it for a second. I could be wrong. Yeah, that's nice. What's that dirt on the right side of the hood? That's just dust. That's just dust and stuff from the day, guys. This was driven here. It's an Ascona, not a Manta. It's all the same. No, that's cool. Thank you. I looked at it quick. I gotta look at it quick. It looked like a Manta 400 to me, but yeah, okay, cool. You know, don't worry. Chat will let you know when you're wrong about something, and you know, thank you for making me look like a fool. You know, after I just said I know my European cars. Clearly that's not true. But hey, I will, unlike some other people, take accountability for my actions. I was wrong. See? Is this hard? This is not difficult. This is not a difficult thing to do. I will make sure I get it right next time.
Discovery, go at throttle up.
Is this difficult? No, it's not. You know? Is that difficult? No. Easy. Done. Now we don't ever have to talk about it again, just like some other people. Am I right? See? That's what's called a correct equivalency. Yeah, as opposed to a false equivalency. Oh, we're still talking about it, huh? All right, anyway. Canada, 5-month resub. Thank you very much. All right, what else do we got? Tessa, you wanted to link me to no, the AC Cobras weren't Ford infused. Shelby, sure, and the big V8 in and flared it. Then AC made kit Cobras. They're as common as muck over here. You can get them brand new for 100. Oh, yeah, Tessa, they're common as muck. You can get them brand new for 150,000 pounds. Do you listen to yourself talk sometimes? You need to take accountability now. What the hell? Do you listen to yourself talk? Oh, yeah, it is common as dirt, 150,000 pounds. Oh, you could get the kit version for about 30K. Dude, no, the AC put that 427 in it first, and then the Shelby Cobra came after that. That's the same thing. Ooh, what's that? Feels ye old. Look at that thing. Does it say Protoss on the front? I don't know what that is. It's an old car though. That's cool. No, Shelby did it to the AC Cobra, 100%. Well, thank you for the clarification. I appreciate it. Let's see. Chat. Mars. Yeah, no, it's you know, it's annoying, but hey, what can I do? I could sit here and deflect or say I'm wrong. It's still annoying, but it is what it is, you know? But the point is that I can admit when I'm wrong about things. I'm not like some crazy person, you know what I mean? Only a little bit, maybe a little bit crazy, but been meaning to ask you your thoughts on the space startups concept. Please have a look. It's just New York Times wants my money, so yeah, no, I can't take a look. I can't take a look, Sile, by New York Times own admission. How about the GT90? Yeah, it doesn't really do anything. Cool car, Chief, but it doesn't do anything for me. They're still doing helicopter on Mars. Yeah, they did the 26th flight. If didn't pay well, I'll try a different link. Yeah, it's all good, man. Yeah, anybody that's gonna call me out on having an ad blocker for their, 500-word news story, I don't care. Yeah, then they can. You can keep your 500-word story. Please see their website. So what is this? What do you want me to see? Inversion? What is this? Build the first high-cadence return vehicle for commercial and defense industries. With the applications of global delivery of supplies, space station resupply and return, and resource return. Okay. All right, that's cool. How are you going to get it up there? It looks like just a micro capsule that you can use for small downmass capability. That's pretty neat. Yeah, that's kind of cool. Yeah, like a microsat return vehicle. Yeah, that's neat. I'm wondering how they're going to get it up there, but yeah. Neat. Cool. Yeah. Okay. Yeah. That's pretty neat. Why did they blur out where they are? What's the page for NASA's white papers? NASA Technical Resource Archive, NTRS. Sile, that seems pretty neat. I don't know what else you want me to see. That's cool. That's a little bit overexpanded, but then again, vacuum testing. Wasn't Ingenuity only supposed to have like a month or something? Well, that's what they base rated it for, Reagan. That doesn't mean that it can't do better. That means they're going to do it until it doesn't break. Yeah, there's a pressurized system. Is that a spark plug that I saw there? What's up with so many startups now? Do you think many of them will survive? Is there even that big of a market? Well, there's a thing about spaceflight market demand, and tactical people have theories on it, right? Like, I have my own theories about how it's going to work and stuff. You know, I guess an economist would say no, probably not, right? But I don't know for sure. It really depends. It really depends, and I don't have a crystal ball. I can't tell you if all these companies will survive, obviously, right? Like, that's pretty straightforward stuff. I can't predict the future. That'd be really cool if I could, but estimates suggest that the aerospace market will triple over the next 7 years to $1 trillion industry. So yes, very much yes. Rocket Guy, that's where I'm going. That's the estimate. All right? And it really comes down to this. Like, is rocketry or sending things into space or the commercial space market, whatever, is that going to be something that grows because you have the capability? Or is that capability addressing a need? Right? So let's rewind 150 years. The horse. The horse grew out of a need, right? That is a need of transportation. A human can walk just like a horse can, right? But riding on a horse is easier. So that was a need. You can connect things faster, right? Right? There wasn't that was needed to be a pioneer in the West, right? You needed to have a horse if you wanted to do anything, right? And then, fast forward to the turn of the century, right? 1900, 1901, 1902, right? Henry Ford comes up with the car. He starts mass producing the car, right? Benz is the guy that came up with the original automobile, the Daimler-Benz Motorwagen, in 1898. Henry Ford says he's going to mass produce cars. And the funny thing is that people at the time asked the same exact question. Are cars going to be sustainable? And then because people saw the potential with mass producing an automobile, all these other startups popped up. Other startups like Oldsmobile, Cadillac, Mercury, General Motors a little bit later, Chevrolet. All these other startups started popping up, right? And were all of them going to last? No. But 150 years ago, it was all about the horse. You needed to have a horse. 50 years ago, it was a car. You needed to have a car to do anything. Nowadays, not so much. But was there a demand for cars when Henry Ford started making cars? No. But that became a market. That became something that was normal. You take like airplanes, right? Airplanes are the same thing. The Wright brothers in 1903, or Santos Dumont, if you think 14 Biz is an airplane, or the Wright Flyer is an airplane. I don't care. They both are, but they both aren't. The plane came around, and it originally started. The demand was like for military reconnaissance, right? It was a small thing that you could fly over enemy territory and see what they're doing. But the funny thing is that drones are doing that exact same thing nowadays, which is weird. And then, people, let's drop a couple of explosives from this thing. And, then there was high military demand. And because of that high military demand, you got commercial markets, right? And then the commercial market became a thing, right? So, like, tactical, like, it really comes down to how that market will transpire. There are projections that it's going to grow like crazy. But is it going to be something that's going to last? I don't know. Are all these startup companies going to last? Probably not. Some of them will probably end up merging, like what happened with the automotive industry. Studebaker and Hudson, they ended up merging in with Nash and a couple of other things. Like even in the 30s, there was Auto Union in Germany. Auto Union was a combination of four German car manufacturers. They all consolidated, and they made Auto Union or Audi. And then Audi itself was bought by Volkswagen. That's most likely what's going to happen. The technologies are going to get scooped up. I don't think these companies will go away per se, but there will be some consolidation as the market grows because that's just how market economics work. Oh, that's neat, Sebi. So, I don't know. Like, it's projected to grow. I think spaceflight and commercial space is here to stay. But, in 1996, if you asked me the same question, I would have the same answer. Oh, yeah, I think it's going to grow like crazy. And then the dot-com bubble happened. And then it didn't grow like crazy. It literally washed up. It went in the other direction, practically to zero. To the point where the government had to pay via a contract, not a subsidy. They had to pay to keep launch pads operational for rockets for defense satellites. The market demand basically went to zero. So I don't know. You know? I'm not sure. I think it will grow. Will I think these companies survive? No. But I don't think they're going to go bankrupt either. They'll just merge and consolidate and the IP will get absorbed by another company. I think that's what's going to happen. I mean, SpaceX is already doing that. SpaceX, Blue Origin, if they, say Blue Origin wants to make an antenna for their new satellite constellation, they'll look around for a company and they'll buy the company. And they'll absorb it into Blue Origin. So, I don't know. I don't know, Hand. Yeah, Tactical, it really... SpaceX has created their own demand. Yeah, got nukes. Yeah, that's a good point. Tactical, SpaceX made their own demand. They turned the rocket, instead of demand for a launch vehicle, they turned Falcon 9 into just a means for another avenue of revenue. Another channel of revenue. They found another way to make money, and rockets are needed to make that money. That's the plain English way of saying it. They made Starlink, and Starlink could potentially be super profitable, way more profitable than launching rockets, but you need to launch the rockets to maintain Starlink. They made their own internal demand, and that in itself is growing the industry because people see the profitability of internet satellites, and other people say, oh man, I should do that too. OneWeb is a good example of that. Project Kuiper with Blue Origin, and then I think there's another one, I forget the name. Yeah, Elia, there you go. I can't imagine all the Starlink launches with Starship. Yeah, well, I mean, Tactical, it makes sense from a business standpoint to have a fully reusable launch vehicle so you can maintain the Starlink network. Because once again, the Starlink network, dude, Morgan Stanley evaluated Starlink, I think. Starlink in itself, the company, at like an $80 billion evaluation, like just that subset of SpaceX. The potential for utilizing or for giving internet to underserviced areas that the telecom companies like run-of-the-mill ISPs it doesn't make sense for them to run a line out there. Anybody that lives in the sticks knows exactly what I'm talking about. It doesn't make sense for high-speed internet to be put in rural areas because there's not enough profitability there to run the line out. It's going to cost you $1 million to put the line out there for a couple of people that pay $50 a month for internet. You're never going to see a return on investment from that. Now, don't get me wrong. Is that a crappy way to think? Personally, I think so. Yes, I think if, just like SpaceX, if you build it, they will come. Sure. I don't like min-maxing businesses like that. I think that's a really short-sighted thing to do, but that's how that works. So, fine. Elon saw that and said, all right, fine, sweet. If you have a satellite that costs next to nothing to launch into space because it's your own damn rocket, and you've put the development in on making a reusable rocket, well, you make your own demand for satellites. And if Starlink captures all that underserviced areas, dude, there's a lot more rural places in this world than there is cities. A lot more. There's a lot more. Rip, Bradley. Well, there's a lot more. There's a lot more rural areas on this world than there is cities. So, I've said, and this is just kind of made up, not off any particular numbers, but I've said that if Starlink captures like a percentage of global telecommunications, Elon will become a trillionaire very fast. Very like trillionaire. Screw the Tres Comas Club. All right? No. In a town of about 500 people, it was really a loss. Yeah. The first to the capsule market. Cool to see inversion go for it as hell. Go for it as well. I haven't seen the need for a capsule yet. You got to build the market somehow. Bingo. Haven't come across the need. Yeah, Rocket Guy, exactly. You know, and that's the kind of stuff that I'm talking about. Like in the case of inversion, you know, they're making a small sat capsule, a capsule that could, you know, down mass capability for a small sat. What if, you know, a company that launches these small sats, instead of just the small sat, you have the capsule with it so the small sat can come back down? There might be a market there that you don't. There might be a market there that nobody would anticipate. Say you build a satellite constellation of small internet satellites, like Starlinks. Maybe a tiny little capsule is needed for those. So when they come back down, you can get your satellite back and then upgrade it and then send it back up again. You won't know until you try. You know, can you imagine a small sat thing, Rocket Guy? Like a small sat satellite constellation with that on it? Like, there could be money there. That's possible. But it's like the car, you know. Henry Ford was insistent on mass producing this to get the price down, right? And I'm sure he got 1,000 naysayers in the press saying, you're never going to make money off that. You're never going to make money off that. You're never going to make money off that. And you know what? A couple of years later, Henry Ford was laughing all the way to the bank. Because people didn't realize that they needed a car. A horse can do everything that a car can objectively. A car is way easier to operate. Way easier to operate than a horse. Am I right? It requires a lot less maintenance than a horse does, that's for sure. You don't have to feed a car every day. Unless it's gas guzzling like mine, but then you kind of do. But then again, I don't drive my cars. I work from home. I drive them on the weekends for fun. You know, but it's everybody realized that, you know, nobody scratch that. Nobody realized they needed a car until the car came along in mass numbers. And then they're like, now everybody has a car. So, you know, that's the thing about the spaceflight market. I don't know. It might grow. Might not, you know, like we could have a crazy event like tons of inflation happening because of a global pandemic, you know, and that could screw it up. Please God, no. You know, like you don't know, like the dot-com bubble bursting killed the space market in the 90s. That absolutely happened. That's part of the reason why, you know, when SpaceX was first coming along, they saw the prices for Delta IV and they saw the prices for Atlas V, and they're like, wow, these rockets are so expensive. Why are they so expensive? We can make it for cheaper. We can make it for cheaper, which is pretty damn correct. But you got to understand is, what everybody has to understand is that Delta and Atlas were built in anticipation of a market that never came. Think about it like this. You built and engineered, you built and engineered a semi-truck. And a semi-truck, anybody that operates a freaking truck knows this. The best way to make money off of the semi-truck is to have the semi-truck moving things around. If you bought 500 of these things in anticipation that all of them are going to be used, right? And then the market crashes and you end up using only 50 of them, well, the cost of operation of that truck is going to skyrocket. Am I right? That's part of the reason why Delta IV, Space Shuttle, you know, well, not so much the Space Shuttle. The Space Shuttle kind of, but that's for other reasons. Why Delta IV, Atlas V, why those vehicles ended up being so dang expensive 10 years ago when Falcon 9 came along. They were expensive because there was no market. And the government was, via contracts, not subsidies, was paying ULA to keep those rockets going. So it was literally, that's the like maximum price that they were super expensive because they don't fly very much. But the way Delta IV gets put together, the way Atlas V gets put together is designed to go quick. They were anticipating something like Starlink happening, where you're going to launch once a week. If you build out all the infrastructure that you need to launch once a week and end up launching once every 3 months, well, yeah, cost of operation is going to go through the roof. You're going to skyrocket. Am I wrong? I mean, that for different reasons, that's the reason why the shuttle ended up being so dang expensive. because what they were anticipating with the shuttle is flying basically on the frequency that Falcon 9 flies right now, once a week. And if you did that with the shuttle, eventually the costs would go down. And they were trying to do that, but then Challenger happened, and then they said, nah, let's fly it less, not more. Skyrocket. Yeah, you see what I did there? The wheels ain't turning, you ain't earning. No matter what, launch industry needs to stop getting all of the investment. No matter what, launch industry needs to stop getting all of the investment, and very soon. Hope to see that investment bubble pop. Space segment needs serious capital to innovate now. Yeah. 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 And Atlas 5 and Delta 4 wouldn't have existed if the shuttle was allowed to do its job. Yeah, on a side note, gosh, sure. You can see some of the camera views Mission Control has in these for SLS. Okay. Oh. Firing room Juan. Novus, I know spaceflight is about application and stuff. I get it. Can we go back to consoles, please? Can we? Was that George Lucas in the back? I highly doubt it, but it does look like him. Yeah, look at that view. Oh. Yeah, that's like an E8 style camera view right there. Oh, the one from the side with the TSMUs. Oh, that's cool. What's this other one, Novus? Let me see. Hey, thermal. Look at that. They got a FLIR. Cool. Oh, that's so sick. See, even these guys got a little better. Like, you know, the consoles, man. It's got to be consoles. You got to have a console. It's spaceflight. You have to have a console. Ew. Yeah, telemetry view. UI telemetry view. Look at that. That's cool. Oh, this is sick, man. Wonder how good the deal was on all those Dell monitors. Pretty good. Dude, what if... You think people would go for that? For what it's worth, it's still called on console. Yeah, yeah, yeah. What if... Okay, I'm snowballing here. Who here is a child of the 80s and 90s? Arcade boxes, right? What's an arcade box? It's just a computer with a screen inside of a wooden box, right? What if there was like... What if we started a company, Rocket Guy, right? We started a company that's like... You sell consoles that are configurable like server racks. Because every one of these guys that I see... Every one of, you know, it's not just NASA, right? You know, it's just a bunch of it's just a bunch of computers kind of sitting down. What if we sold flight control, like found a way to like mass produce a certain type of arcade box flight control thing that had everything that you need in one package? Spitballing, snowballing is something completely different. I'd argue that both of them mean, yeah. Anyway, moving on. Right? Like a standardized console. Like, oh, You know, you could, this is your console, like, you buy this instead of buying a table with a monitor mount, right? So your mission control doesn't look like a freaking LAN center. And you use that, and you can configure it, right? You could buy the monitors that you want, and you could put it in there, you know? Very low demand. People want slick and minimal these days. Well, I'll just have to build one myself, then. You like the LAN center vibes? Is EJ frozen for anybody else? I don't know what you mean. I know what it means, Dish. You're the only one that's thinking about it, though, which is a little strange, okay? It's a little weird, man. Not gonna lie. I agree with Fractal thing about Rocket Lab's mission control. It's really good. You're not thinking fourth dimensionally. That hand was shaking. Here, is this finger shaking right here? Please tell me. Look real close. Look real close. Is that finger shaking right here? Sorry, I couldn't help it. You are frozen. I can't tell. It's moving. It's shaking too fast. No, I need you to just look real close for me. Just look real close. Just look here. Just see. Just look real close. Just look real close. What? I just wanted you to see my ring finger. It's not shaking, is it? No, it's fine. Sounds like we need to create a GitHub with open source satellite designs. Yeah. What can you say about Apophis? I don't know what that is, Corvus. What's up, Animal? How you doing? It means peace among worlds. Okay. Yeah, fall. Yeah, exactly. Something like that. I'm telling you, one-stop shop for, like, flight control desks. It could work. Also, Ritz crackers. Very... Are those munchkins? Yes. And donut holes. Oh. Bro, famous Amos. Famous Amos. Nice. Very nice. Very good. Very good. Donut holes, you mean Timbits? Timbits. You and your Canadian gibberish. No. I don't, man. No. Anyway. Yeah. Oh, hey, look at that. Check out that view right there. That's inside of the ML. Look at that. Look at that. That's pretty neat. Got thermals. We already saw that. Got guy that looks like he wants to say, get off my lawn. No, I'm sure that guy's cool. Uh-oh. 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 Not like this. Peep the big screen in the center. Oh. Oh, that. Damn it. No. Here, let's just look at some wood. All right, cool. That's sick, man. See, dude, why couldn't... Just... Honestly, just a rotating feed of, like, that camera and a couple of other things, it would be... You don't even need to broadcast the countdown loops, just that. I heard you like wood. Keep the patch on the top right. Hail stick. No. Top right. Top right. Sure, RB. You know what? You know what we're doing? You know what we're doing now? Just because of that? You know what we're doing? Here's what we're doing.
Nine, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X, testing concepts for the future of new rocket design.
Altitude now 2
Nice
miles.
ones.
Chamber pressure now tapering off.
No,
as
not
designed.
broomstick.
Vehicle is aligned
This
itself
is
with
my
the
boomstick! Anyway.
We passed Mach 1, and we're now passing Max Q. We have our Max Q system ID maneuver PTI engaged. Now passing Mach 2.
What an awesome
vehicle now
vehicle.
10 miles altitude, downrange distance 8 miles, and a velocity of 1,540 miles per hour. Plus 80 seconds, we've started our supersonic large amplitude ID maneuver PTI. We see the response.
Biggest Duckus. Yep. Yep, more consolation prizes. Not constellation
And we started
prizes.
the last
differences.
PTI maneuver, structural mode ID, and we passed T plus 105 seconds.
That was the last rocket to launch from 39B, by the way. Is the grain packed in a way where the thrust decreases during expected time of max Q? Of course, someone. They pack the segments differently.
Now traveling
Yep.
Mach 4, 20
Oh,
miles
yeah.
altitude.
More
downrange
segments, you have more
distance
control
32
over the
miles.
thrust curve. Absolutely. Yep.
The SRM tail off is observed.
TLDR Y Ares was dropped. Sile, you remember when I had the thing about that OIG report about sustainability in the program? Literally the same excuses that they're making right now for the SLS program, they made for Constellation. Yeah. Yep. That's the short answer. Yeah. Oh, nice, Pigzig. There you go. Sile, I believe at the time they said that they would end up saving more money in the long run, switching completely to commercial. That was the argument. That's not a bad argument. I don't particularly think that's a bad argument, like saying that you're going to save money flying on commercial. But the part that they failed to say is that you're going to save money launching on commercial because you're not going to launch at all. Yeah, they didn't finish the statement, and that was on purpose. They didn't say that part on purpose. Yeah, they took the best part as no part, and they kind of went a little extreme in that. Yeah, Mars, that's a great picture. You should change the name of Project Ares to Project Clean Sweep if you're going with a broomstick design. Oh my god. Thomas, what's this? Oh, now that's a neat picture. I don't hate that picture. See, Alex, you know what the funny thing is that we can easily do both of those things. Yeah. Stupid. That's sick. That's the Crew 4 SpaceX crew with Artemis 1. They're looking out the window at Artemis 1 and there's the reflection, which is pretty sick. That's pretty neat. All the different mission controls. Let me take a look. Yep. There's Mercury. Yep. Gemini. There's Apollo. Yeah, see. The consoles, man. Consoles are where it's at. Who's taking the picture, though? Don't worry about it. Dude, look at the ground track for something that's on translunar injection. Yeah, that's a little funky. That's a little funky of a trajectory right there. Yeah, that's pretty weird. Long story short, when you try to superimpose a trajectory that goes out to the moon over a map, it starts to get a little weird. The last link was recorded in your hometown. Oh, very nice. Nice train. I like trains. That's cool. That's Apollo Soyuz test project right there. See, that's a low Earth orbit ground track. See the ground track right there? There's who's on console here? Neil Hutchinson is right there. Chris Kraft is right there. Hartsfield around. Yeah, this is SDS-1. Yeah, Hutchinson's on flight direction. That's SDS-1 right there. Question: do you know if the LR-79 ignited midair during Titan 3E launches? Yes. Oh, neat. W, that's cool. Why does the girl have a Batman utility belt? I don't know. That's on roll. No, it's not on rollout because there's people standing next to it. That's right after wheel stop. Cool. Let me take a look here. What mission do we think this is? Well, 27 degrees inclined, so it could be Hubble. Not sure. I can't tell what that is. That's ISS mission control. That might look familiar to some people. ISS mission control here has it has a bunch of mahogany desks and monitor mounts. It looks like it looks like a bunch of streaming setups. Yeah. Yeah. Something's, I don't know what that telemetry view is. Yep, that's what it looks like now. There it is. That's actually a flight control room. That's not ISS mission control. That's a flight control room. Differences. Look at how much wider the mission control center is. These are all different rooms at Houston, to be honest with you. That's a flight control room. Different. That's for controlling a flight, not the station. Watching the Challenger documentary on Netflix, very interesting. Is that the one that J.J. Abrams did, Tundra? Man, did he miss the point. It's kind of like ridiculous. Did NASA always have forward projected screens in mission control? Thought it was back projected for the first few decades. I'm not 100% on that. Jar Jar Abrams. Indeed. Here, have a lens flare. Alright. Fellas, it's break time for me. Do you want to do a little bit more space news, like Starship update on the other side of space news? I'm going to take break middle space news, and then we'll play Kerbal after that. Wait, you have monitors instead of consoles in your mission control too. I don't, and they're 4-3 monitors. It's weird, man. Alright, here. I got a video that people would probably like. Here. It's an old one, and I've shown it before, but you guys will like it. Here. Did you cover the new flyover? No. This space news has been a little fragmented, Vasia, because we started with launch coverage, and I started it at 2. So yeah, it's kind of, this is just kind of more just talking about space, not necessarily space news. We could do a more regimented space news on the other side of break when I get back. I will be back. Not JJ, it says Stephen Leckhart. Interesting. Okay. Yeah, it was audio only. I mean, yesterday. No, I didn't get a chance to show that. Link it up when I get back. I'll be back momentarily, guys. I'm just going to take a quick break. Just going to go grab a bite and get more engineering juice. And we'll be back. All right. Be back in a little bit. Here, I got a good video for you in the meantime.
When ancient man looked to the heavens for guidance from the gods, he noticed star patterns and began to document their movement across the heavens. The ancients believed that the earth was flat, but around 350 BC, Aristotle proved that the earth was round. Later, about 150 AD, Ptolemy presented the geocentric theory, the belief that the earth is stationary at the center of the universe, with the sun, moon, stars, and planets revolving around it in complex orbits. In the 1500s, Nicholas Copernicus of Poland presented the heliocentric theory, the belief that the Earth revolves around the sun as it rotates on its axis. This aspect of astronomy evolved into an intricate study of planetary motion known as orbital mechanics. Today, orbital mechanics is applied to space flight and satellites that orbit the Earth or travel beyond our solar system. In the early 1600s, Johann Kepler, a German mathematician, using the data on planetary observations collected by the Danish scientist Tycho Brahe, developed 3 laws of planetary motion. Kepler's first law states,
all planets move in elliptical orbits with the Sun at one focus and the other focus empty.
applied to Earth satellites, the center of the Earth becomes one focus, with the other focus empty. For circular orbits, the 2 foci coincide. Kepler's second law, the law of areas, states,
The line joining the planet to the Sun sweeps over equal areas in equal time intervals.
when a satellite orbits, the line joining it to the Earth sweeps over equal areas in equal periods of time. If areas 1, 2, and 3 are equal, times 1, 2, and 3 are also equal. Therefore, the speed of the satellite changes depending on its distance from the center of the Earth. Speed is greatest at the point in the orbit closest to the Earth, called perigee, and is slowest at the point farthest from the Earth, called apogee. It is important to note that the orbit followed by a satellite is not dependent on its mass. A large, heavy satellite could be in the same orbit with a small, light one, each sweeping out equal areas in equal periods of time. Kepler's third law, the law of periods, relates the time required for a planet to make one complete trip around the Sun to its mean distance from the Sun.
For any planet, the square of its period of revolution is directly proportional to the cube of its mean distance from the Sun.
Applied to Earth satellites, Kepler's third law explains that the farther a satellite is from the Earth, the longer it will take to complete an orbit, the greater the distance it will travel to complete an orbit, and the slower its average speed will be. Isaac Newton, the father of classical mechanics, laid the groundwork for orbital mechanics. He combined the work of Kepler and others to formulate the law of universal gravitation and the three Newtonian laws of motion. While Kepler's laws provided a conceptual model of orbital motion, Newton's laws provided the foundation for the mathematical description of orbits. They explain why a satellite stays in orbit. Newton's law of universal gravitation.
Any two objects in the universe, such as the Earth and the Moon, attract each other with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them.
Stated more simply, the more massive the objects are, or the closer they are, the greater the gravitational pull between them. Newton's first law of motion.
A body in motion will keep moving at the same speed and in the same direction unless acted upon by an external force.
A satellite moves in a curved path around the Earth because the Earth's gravitational pull acts as an external force on it. Newton's second law of motion.
If the sum of the forces acting on an object is not zero, the object will have an acceleration proportional to the magnitude and in the direction of the net force.
Newton's second law states that force equals mass times acceleration. It is this mathematical equation and the equation for universal gravitation that forms the basis for calculating orbits. Newton's third law of motion explains how a satellite gets into orbit.
For every action, there is an equal and opposite reaction.
If you blow up a balloon and let it go, the balloon is pushed forward by the action of the air rushing out of it. A rocket's exhaust gases are like the air rushing out of the balloon. The following illustrates how a satellite stays in orbit. If a man stands on a mountain and fires a projectile horizontally, gravity will cause the path of the projectile to curve downward and it will strike the Earth. However, if the man fires the projectile fast enough at a specific speed, the curvature of its path due to gravity will match the curvature of the Earth under it. The projectile will then fall around the Earth, becoming an Earth-orbiting satellite. A projectile fired even faster will have a flight path away from the Earth, but gravity will act to slow the projectile down, change its flight path, and pull it back toward Earth. If the projectile's velocity increased enough, a velocity sufficient to escape the Earth's gravitational pull will be reached. This velocity is known as the escape velocity. It is equal to about 7 miles per second at the Earth's surface. The preceding description did not consider atmospheric drag and the Earth's rotation, both of which will affect the trajectory of the projectile. It illustrated the principles governing a satellite's orbit. There are 6 numbers called the orbital elements, which specify the size, shape, and orientation of an orbit in space, as well as the location of the spacecraft in the orbit. Based on an orbit which is an ellipse, the 6 orbital elements are length of the semi-major axis, eccentricity, inclination, right ascension of the ascending node, argument of perigee, time of perigee passage. The major axis of an elliptical orbit is the line joining the perigee and apogee. This line is also referred to as the line of apsides. The first orbital element is the semi-major axis. It is simply 1/2 the major axis. Circular orbits have no apogee or perigee. Therefore, the semi-major axis is simply 1/2 the diameter of the orbit. The semi-major axis is used to define the size of the orbit. From this, the orbital period, or time that it takes for the satellite to complete one orbit, can be calculated. The shape of an orbit is defined by the second orbital element called eccentricity. For all ellipses, the value of eccentricity lies between 0 and 1. The larger the value, the more elliptical the orbit. A spacecraft in Earth orbit with an eccentricity equal to or greater than 1 will escape the Earth's gravitational field. When orienting an orbit in space, a 3-dimensional coordinate system must be defined. The coordinate system commonly used is the geocentric equatorial coordinate system, which has its origin at the Earth's center. This coordinate system is a non-rotating reference system in which a satellite's orbital plane tends to remain fixed relative to the stars while the Earth turns beneath it. The XY plane is the Earth's equatorial plane. The positive x-axis points to the vernal equinox. This is the point where the sun appears to cross the Earth's equator on its way north on the first day of spring each year. The z-axis is along the Earth's spin axis toward the North Pole. Nodes are points in a satellite's orbit which intersect the Earth's equatorial plane. The ascending node is the point at which the spacecraft crosses the equator going from south to north. The descending node is where the spacecraft crosses the equator going from north to south. The line joining the 2 nodes is called the line of nodes. The orientation of an orbit is determined by 3 orbital element angles. The right ascension of the ascending node is the angle between the x-axis and the ascending node. It is always measured eastward from the direction away from the vernal equinox in the Earth's equatorial plane. The argument of perigee is the angle between the ascending node and the point of perigee. It is measured in the orbital plane in the direction of spacecraft motion. Inclination is the angle between the equatorial plane and the orbital plane. A satellite which has an eastward velocity component at the ascending node has an orbital inclination lying between 0 and 90 degrees. Such an orbit is called a prograde orbit. A satellite which moves due north at the ascending node is in a polar orbit. Polar orbits have an orbital inclination of exactly 90 degrees. A satellite with a westward velocity component at the ascending node is in a retrograde orbit and has an orbital inclination between 90 and 180 degrees. The 5 orbital elements explained thus far describe the size, shape, and orientation of the orbit in space. The final element is a time value used to locate the satellite in its orbit. A satellite moves in a very predictable manner. It stays on schedule. Thus, if the time at which a satellite passes a particular point is known, the time when it will pass any other point can be determined. The particular point chosen is perigee, and the time of perigee passage is the last of the 6 orbital elements. The 6 orbital elements depict a spacecraft's orbit in non-rotating coordinates. To visualize an orbit relative to the rotating Earth, a projection traces the spacecraft's position on the Earth's surface. The projected path is called the ground track. As a satellite orbits the Earth, the ground track shifts westward. There are 2 causes for this. First, the primary contributor is the Earth's rotation toward the east under the orbital plane. Second, because the Earth is not a uniform sphere and bulges at the equator, its gravity is greatest at the equator. This causes the orbital plane to rotate slowly around the Earth's polar axis in a motion called precession. Precession is toward the west for prograde orbits and toward the east for retrograde orbits. For low Earth orbits such as those of the Space Shuttle at 150 miles altitude, the westward shift of the ground track due to the Earth's rotation is about 22.5 degrees, while the shift due to precession is only about a half degree. The inclination of a satellite orbit determines the north and south latitude limits of its ground track. The minimum orbital inclination is equal to the latitude of the launch site and is achieved by launching due east. For example, if a satellite is launched due east out of the Kennedy Space Center, which is located at 28.5 degrees north latitude, its orbital inclination will be 28.5 degrees, and the limits of its ground track will vary between 28.5 degrees north latitude and 28.5 degrees south latitude. If launch azimuth or direction of flight at launch measured eastward from due north is increased from due east, the orbital inclination angle increases as well as the maximum latitude of the north-south ground track. Therefore, the latitude limits of the ground track equal the new launch inclination. Similarly, if launch azimuth is decreased from due east, orbital inclination once again increases as well as the latitude limits of the ground track. The maximum practical inclination from a Kennedy Space Center launch is 57 degrees. This limit is imposed for safety considerations in order to keep the spacecraft and its booster system from flying over land masses during the ascent phase. To obtain an orbit with an inclination greater than 57 degrees, the spacecraft is launched from Vandenberg Air Force Base in California. Vandenberg offers the opportunity for southerly launches with orbit inclinations between approximately 70 degrees prograde through 138 degrees retrograde. A significant advantage of launching from Vandenberg is the capability to economically achieve polar orbits with ground tracks covering all latitudes, from the North Pole to the South Pole. The Earth is constantly turning, and all points on its surface have an eastward velocity, with the greatest velocity occurring at the equator. The farther the launch site is from the equator, or as launch azimuth is increased or decreased from due east, less of the Earth's rotational velocity will be imparted to the launch vehicle. This requires more fuel to get into orbit, or payload weight will have to be decreased. Launches due east from a position on or near the equator, such as the Kourou launch site in French Guiana, used by the European Space Agency, acquire the advantage of a free velocity gain of about 1,500 feet per second. This compares to the approximate 1,300 feet per second gain available at the further north latitude of the Kennedy Space Center. Launching from an equatorial site offers a significant advantage in payload weight capability and minimizes the amount of fuel needed to achieve an equatorial orbit. Since many satellites operate in equatorial orbits, these are important considerations. Spacecraft are launched within a specified time interval called the launch window. Some of the factors affecting the launch window are launch and orbit lighting conditions, sun angles, payload orbit requirements, rendezvous phasing if a rendezvous is planned, tracking and communication requirements, and collision avoidance with other orbiting objects, to name a few. One of the factors defining the launch window for the Space Shuttle is launch lighting conditions, which can be illustrated by plotting time versus day of year. On this plot, we see daylight and darkness at the launch site. The longer daylight hours occur in the middle of the year, summertime. If daylight conditions are required for a convenient emergency landing site for the Space Shuttle, the launch window would now look like this. During the winter months, the available launch window for lighting conditions alone can be as little as 3 hours per day. When combined with the many other launch factors, the launch window becomes even more constrained. The choice of a particular launch vehicle for a mission depends upon the weight and size of the payload and the desired orbit. Expendable rockets used to place spacecraft in orbit usually consist of several stages that may incorporate both solid and liquid propellants for propulsion. When the fuel in each stage is depleted, the spent stage is jettisoned. Staging offers the advantage of discarding weight when it is no longer needed. The Space Shuttle is a two-stage system. At liftoff, the 2 solid rocket boosters and 3 Space Shuttle main engines are all producing thrust. After approximately 2 minutes of flight, at an altitude of 25 miles, the fuel in the solid rocket boosters is depleted and they are jettisoned. The 3 main engines, fueled by liquid oxygen and liquid hydrogen carried in the external tank, continue to burn for several minutes until the shuttle reaches its cutoff velocity. At this time, the main engines are shut down and the external tank is jettisoned. 2 additional burns using the orbiter's maneuvering system, referred to as ohms, are required to place the orbiter in its final orbit. The ohms 1 burn occurs about 2 minutes after main engine shutdown and establishes the orbital apogee point. The ohms 2 burn takes place approximately 30 minutes later and circularizes the orbit. Once satellites are launched and put into orbit, it is often necessary to change the orbit with an on-orbit burn. The common term used in describing on-orbit burns or engine firings is delta V. Delta V is the incremental change in spacecraft velocity measured in feet per second resulting from the burn. The amount of fuel used during a burn depends on the desired delta V change and the mass of the spacecraft. Because the amount of fuel carried is limited, fuel consumption is one of the primary considerations in spacecraft mission planning and is critical to orbit lifetime. On orbit, a spacecraft can thrust in any direction. Burns along the flight path, forward and backward, are the most common. A unique feature of any orbital burn is that if no other burns occur, the spacecraft will later always pass again through the point of burn. Forward burns increase the spacecraft's velocity and are known as posigrade burns. With posigrade burns, the flight path of the vehicle will be raised at all points except the burn point. Burns opposite the direction of flight, which slow the spacecraft down, are called retrograde burns. For retrograde burns, the orbit will be lowered at all points except the burn point. The greater the delta V, the greater the difference between the pre-burn and post-burn orbits. Burns can be combined into maneuver sequences to change orbit size, shape, or orientation. One of the most common maneuver sequences is made up of two burns and is used to accomplish an orbit transfer between two circular orbits in the same orbital plane. The most energy-efficient transfer between two orbits of this type is the Hohmann transfer. The Hohmann transfer is actually 1/2 of an elliptical orbit with its perigee in one of the orbits and its apogee in the other. The burns occur at the perigee and apogee of the transfer orbit. The use of the Hohmann transfer minimizes the delta V required, thus having the advantage of using minimum fuel. The disadvantage of the Hohmann transfer is that it takes longer than most other transfers. The type of the transfer sequence depends on the mission and the amount of fuel available. For example, a space rescue where time is critical might use a fast transfer, while a routine satellite deployment where fuel saved for later use is important would most likely use a Hohmann transfer. The burns discussed so far have all been maneuvers in the original orbital plane and do not affect orbit inclination or node position. There are situations which require an orbital plane change, such as setting up a rendezvous or placing a satellite in an equatorial orbit. To change the inclination, the thrust vector must be directed at an angle to the orbital plane. A thrust with a component that is perpendicular to the orbital plane at either the ascending or descending node will rotate the orbital plane about the line of nodes. A northerly out-of-plane thrust at the ascending node will increase the inclination of a prograde orbit, while a southerly thrust will decrease it. Out-of-plane thrusts require considerable amounts of fuel and are performed only when absolutely required. The Space Shuttle, for example, using all of its onboard propellant, is capable of an on-orbit plane change of less than 3 degrees. Satellite orbital planes and altitudes are determined by their design mission, which very often includes a field of view requirement for optical or communications purposes. The field of view of a satellite is defined as the area of the Earth's surface that is in view from the satellite at any given time. Satellites in high orbits have greater fields of view than those in lower orbits. For example, a satellite at an altitude of 800 nautical miles has a circular field of view with a diameter of about 4,100 nautical miles. A satellite at 200 nautical miles has a circular field of view with a diameter of about 2,000 nautical miles. Low-orbit satellites are often used for photography and other types of Earth observation. A satellite placed in a low inclination circular orbit at an altitude of about 19,300 nautical miles will have an angular velocity exactly equal to that of the Earth's. The satellite would seem to remain stationary in longitude as viewed from the ground. Such orbits are called geosynchronous and are used to provide a continuous communications capability among any system of ground stations within their field of view. The geosynchronous orbit field of view is constant and is limited to a latitude zone of about 70 degrees north and south of the equator. Effective satellite communications from geosynchronous orbit is not possible at either pole. However, because of their altitude, their field of view covers nearly half the globe. A special type of geosynchronous orbit with an inclination of 0 degrees is called a geostationary orbit. It appears to hover over a fixed point on the Earth's surface at the equator. Most U.S. communication satellites are in geosynchronous orbits, providing near worldwide communications coverage. For effective communications at high latitudes, the Molniya orbit is used. Molniya is the Russian word for lightning and is an orbit used extensively by the Soviet Union for its communication satellites. The Molniya orbit is highly eccentric with an apogee that is near the geosynchronous altitude and an inclination of about 63 degrees. The satellite slows down at apogee in the northern hemisphere and whips through perigee in the southern hemisphere. This provides communications in the northern hemisphere for up to 75% of its orbital period. Several satellites properly spaced in Molniya orbits can provide constant communications at the northern latitudes. Navigation satellites, such as the U.S. Navy's Transit System and the Joint Service Navstar GPS Global Positioning System, use lower orbits so that a user can receive signals from more than one satellite at any time. Another frequently used orbit is known as a sun-synchronous orbit. These take advantage of the precession of the orbital plane caused by the Earth not being a perfect sphere. All sun-synchronous orbits are highly inclined retrograde orbits which precess eastward around the Earth's polar axis at the rate of 1 revolution per year. Since the Earth-Sun line also revolves eastward at the rate of 1 revolution per year, the orbital plane will maintain a constant orientation relative to the Earth-Sun line. If the satellite's period is then synchronized with the rotation of the Earth, it will pass over the same point on the Earth's surface at the same local time at a regular interval. A sun-synchronous satellite ensures that a constant sun angle and uniform lighting exist for the same field of view from pass to pass. Satellites such as those in the Defense Meteorological Satellite Program and Landsat are sun-synchronous, imaging the entire Earth on a regular schedule. The gravitational attraction of the Earth on a spacecraft causes it to move in its orbit around the Earth. There are other, much smaller forces which will cause a spacecraft to deviate from its desired orbit. These forces cause what are known as orbital perturbations. Orbital precession, which is used to obtain sun-synchronous orbits, results from the perturbing effects of the Earth's non-spherical shape. Other perturbing forces are the gravitational pull of the Sun, the Moon, and planets, and solar winds, which are charged streams of protons and electrons that heat the Earth's atmosphere and increase atmospheric drag. In most cases, perturbing forces can be compensated for in the spacecraft and orbit design and present no major problems. If the forces disturb the orbit too much, thrusters can be fired to re-establish its desired orbital orientation or altitude. This is particularly true for spacecraft orbiting at very low altitudes, where the effects of atmospheric drag are greater and, if not compensated for, will eventually cause the spacecraft to deorbit. A spacecraft's operational lifetime is frequently limited only by the amount of fuel available to maintain its desired orbit. When its useful life is complete, a satellite is left in orbit or is deorbited, burning up when re-entering the Earth's atmosphere. When the Space Shuttle completes its orbital mission, it executes a precise retrograde burn to initiate its controlled return to Earth. This burn occurs nearly halfway around the Earth from the landing site. The new orbit established by the retrograde burn causes the orbiter to enter the Earth's atmosphere about 4,000 miles from the landing site. During the period the orbiter descends from its orbital altitude to atmospheric re-entry, its attitude is maintained by the use of reaction control jets located in the nose and tail of the orbiter. Once the orbiter enters the Earth's atmosphere, its wing and tail aerosurfaces begin to become effective and gradually replace the jets for attitude control. As the orbiter nears the landing field, it maneuvers to a long, straight-in approach at an angle of 17 to 19 degrees. Nearing the runway, it executes a flare maneuver to reduce its sink rate and glides to a touchdown at approximately 230 miles per hour. As the orbiter rolls to a stop, our journey into the world of orbital mechanics comes to an end for now. This is only the basics of orbital mechanics, an intricate study of planetary and satellite motion. The next time you see a launch, you will see it from a different, somewhat knowledgeable perspective. You will understand the fundamentals of spaceflight.
Discovery, go at throttle up.
Hey, who shut the movie off? Oh, it's over. Okay. All right. I got you. Oh. Oh, these are nice. What did that flare maneuver before touchdown do to help? Huh? What? Back it up.
Begin to become effective and gradually replace the jets for attitude control. As the orbiter nears the landing field, it maneuvers to a long, straight-in approach at an angle of 17 to 19 degrees.
Yeah, baby.
Near
Land that
runway,
brick.
It executes a flare maneuver to...
Right there? That what we're talking about? EJ, what's that? Alan Shepard suit glove from Project Mercury. Yep, okay. Can't afford that. That's good. What do you think that's doing? Look at this graph! I wasn't mousing over the suggested videos. You were. Huh? So, okay. The shuttle is a lifting body. Style. Lifting body. Meaning that it has these little stubby boy wings on the side, but those wings are just that. They're very stubby comparatively to the size of the fuselage. Okay? So the shuttle has to, if the shuttle is going to generate lift, right, to negate out its vertical speed, right, because the ground is coming, and it's coming very fast, right, you need to generate a good amount of lift. So how does the shuttle generate a good amount of lift? It flares the nose up and exposes the entire belly of the shuttle to laminar flow, and that generates an insane amount of lift. But it can't do this all the time. Why can't it do this all the time? Well, it's a glider. So it basically has to nosedive at the runway, for the most part, like that.
And
has to nosedive at the dang runway, and then right at the last second, you pull up to generate enough lift to not crash into the ground. Yeah. Yeah. Okay, Thunderwolf, I will. Yeah, see what I'm talking about there? It flares at the last second just so it generates enough lift to get no vertical speed and touch the tires down nice and soft. It can only do that for, I don't know, maybe 10 to 15 seconds before it'll stall and fall out of the sky like a brick. That makes sense? I gotta go get my coffee. My coffee's still brewing. That's why I let it go to the suggested videos. The shuttle is an insane piece of technology. Sile, it is. I don't think it gets credit where credit is due. It is ridiculous. You know what? While I go get my coffee, I want to show you something. The dream is alive. All right. This is the beginning of one of the first IMAX documentaries around. This is public resource, or at least I think it is. Nope. Let's try this. Nope. No, they seem to want to scrub public resource off of YouTube. Looks like somebody claimed Dream is alive, which is hilarious. Suggested videos, wink wink. Yeah, right. Here, hold on. Let's do shuttle landing. Yep, it auto-populated it. Alright, watch this thing. This is STS-131, right? I love that people put their watermarks over, over NASA footage. That's cool. Whatever. I guess I kind of do that too, so. Alright. Watch this, and I will be right back, okay? Watch the shuttle right when it goes to touchdown if I'm not back in time. Okay? And look at this thing. Look at how fast it's going towards the ground until the last second. The shuttle... Okay, so look. This footage, right? Let's see. Where does the shuttle land in this footage? It lands about 6 minutes. Okay? In this shot right there, the shuttle is flying higher than most commercial airliners. So from here to there, in about 6 minutes, the shuttle falls about, I don't know, 80,000 feet or something. It's something nuts. It falls like a brick, basically until the last second where they can use the wings to generate enough lift to land. Here, I'll be right back. I'm gonna go grab my coffee.
Discovery Houston, you are on energy approaching the hack. No changes to winds and weather. Go for nominal shoot deploy.
Copy, Houston, nominal shoot deploy.
Discovery will soon be approaching the imaginary circle leading towards the runway that's created by the microwave scan beam landing system. That allows the commander and pilot to guide the vehicle as it makes its final approach to runway 33 at Kennedy Space Center. There, the commander will take control of the shuttle steering once its speed is dropped below Mach 1. It's at 1.2 right now, Mach 1 being the speed of sound. Discovery is currently traveling 800 miles per hour, 68 miles away from Kennedy Space Center, and less than 10 miles in altitude. Discovery will be making its left-hand overhead turn of 200 degrees before it's lined up with runway 33. And Commander Alan Poindexter is now at the controls of Space Shuttle Discovery as it's reached subsonic speeds.
Okay, your boy's back.
Those sonic booms announcing
Yeah, see, look, nosediving at the ground. But it looks right.
Sonic booms announcing Discovery's arrival. It's now just 68 miles away from Kennedy Space Center.
It looks right.
27,000 feet in altitude and traveling 530 miles per hour.
Discovery on at the 180.
The shuttle is the only thing that makes nosediving look correct. Look at the body flap, too. The body flap's trimmed out.
Pilot Jim Dutton now taking over controls of the shuttle for a moment. And that call from Capcom Rick Sturko indicates the shuttle has 180 degrees to go in its turn around toward runway 33. All continuing to look good on board Discovery as it makes its way home.
What's starting soon? Space news
68
is
miles
starting
to go.
soon.
Currently 3
Starting
miles
now,
in
actually.
altitude and traveling 420 miles per hour.
Discovery, you are on at the 90. On at the 90.
He's talking about circling around to the
Commander
runway.
Alan Poindexter now back in control of Space Shuttle Discovery. Just 2 minutes now until touchdown.
That means the shuttle is doing a good. The radius of the turn that the shuttle is taking is enough to line up with the runway when they're done with the corner. That's what that means. You're basically in the track. No times are in place for the return of AX-1. They also indicate a splashdown in the Gulf. Nice.
Houston Discovery, runway in sight.
You know, Thomas.
Roger.
Thomas, those landing and recovery conditions are those are all nice. But you know what's also nice?
Less than a minute and a half
Landing on
until
a runway.
touchdown. Discovery is now descending at a rate 20 times higher and 7 times steeper than what a commercial airline would experience on its final approach.
Who's Roger? See, isn't this a little bit cooler than a capsule
1
splashing
minute now
down in the
to
water?
touchdown. Discovery's landing gear will be locked down.
And I mean, don't get me wrong, the capsule splashing down in the water is
300
cool
feet
too,
in
but this though.
It's currently 3,500 feet and traveling at a rate of 370 miles per hour.
Ah, yes, freedom units.
30 seconds until touchdown.
Yeah, look at the ground come up. Look how fast the ground's coming up. Focus on the ground, not the shuttle, and you'll see the descent rate. It's absurd.
Main gear. Landing gear now down and locked.
There's the flare.
Main gear touchdown. Pilot
That's nice.
Jim Dutton now deploying the drag chute.
How much is that Indigo blocked for flip flap? Yes, sure.
Nose gear touchdown.
This is kind of like China hypersonic glide missiles.
131 mission, the 131st Space Shuttle flight, and the 33rd to the International Space Station.
Hey, Dizer. 38-month resub. Ooh. Ooh.
Discovery left Florida on
Hey,
April
Flight
5th
Sim.
with 7.6
5 subs. Thanks,
tons
man.
of new science equipment and spare parts, including equipment that should improve the station's capability for Earth observation work, equipment that could help astronauts avoid muscle atrophy, and scientists better understand muscle atrophy.
Yeah, pretty much,
that
Flo.
will help keep the station systems cooling properly.
Gravity opens the doors. Actually, that's not entirely true. How the shuttle's landing gear works is that all they're doing is releasing a latch for the doors to open. When there's a lever, all right, that's attached to the doors, and when the doors go down, that lever basically opens the latch for the landing gear to come down. Yeah. The doors accentuate the landing gear. Or the doors, not accentuate, actuate the landing gear, excuse me. So, hold on. Watch, the doors will pop first. And then the gear comes down. See? Doors, and then gear. And yeah, gravity is the only thing that that keeps it in place.
Main gear.
Yeah, XLK, I know what it is, but those are stupid. I like this better.
Landing gear now down and locked.
This is better. This is cooler. You should do this and less of that. If one doesn't come down, could she survive a belly landing? If one doesn't come down, that means gravity has malfunctioned, goalie. I don't think that that's going to happen.
Main gear touchdown. Pilot.
I mean, could be wrong.
Pulling the drag chute. Nose gear touchdown. That brings an end to the STS-131 mission, the 131st Space Shuttle flight, and the 33rd to the International Space.
Oh, we should still be flying that thing. You never know, right? I mean, in that unlikely scenario, could it survive a belly landing? I'm pretty sure if gravity has stopped working, a belly landing is the worst. It's not the worst of your concerns. Am I right? Goalie, I guess yeah, I mean, I don't really want to imagine what would happen to the shuttle if, like, one of the rear landing gear deployed. That probably wouldn't end well. That would be a write-off. Yeah. It'd land. Not sure how many pieces it would be in at the end of the landing, but it would land. I mean, not very well. Yeah, that wouldn't end particularly well. Anyway, would the crew survive? I don't know. Maybe. Yes. No. I mean, you have to understand the contingency of that question, you know? It's like if I was walking along and stubbed my toe and fell, you know, would I survive? I don't know. If you fall and you just fall down onto like a sidewalk, you're probably going to get a couple of cuts. But if you stub your toe when you're walking across a bridge and you trip and fall over the side of the bridge, I don't know. Yeah, probably not. You know what I mean? It's way too contingent to know. You know what I mean? Like, you can't know. Like, dude, honestly, I don't know, man. Yeah, it really depends. I mean, so here's what I would do. If that was a scenario, I would basically, try to get the shuttle. Like, if you had a one gear deploy, like, so your front gear and the left gear deploys, at that point, I would just pull the nose up more and more and more and more and more until the shuttle basically stalls and then belly flops onto the runway. That's what I would do. I mean, crashing down like that is going to hurt, but it's not going to hurt so much as if you try to land like this on one gear and the shuttle flips over and then starts rolling down the runway. that probably would end worse. Yeah, I'll take my chances with the belly flop. Per NSF, a new Falcon 9 booster, 1073, will be joining the fleet next month, making a debut with the Starlink mission. Cool. Yeah, Jake, I'm kind of with you on that one. Yep. Yeah. All right, let's get into some space news. So the first thing I kind of showed on the first part of space news, but I'm gonna get through some of this quick, and then we'll do the Starship update, and then we'll play games from there. Maybe we'll mess around in Kerbal or something. Yeah. I don't know what we'll do. We'll find something. Element, you just got the update. My new car will be here Saturday. That's cool, man. I'm proud of you for what it's worth. Like, if that even matters, am I allowed to be? But good job. It's pretty cool ticking off your goals like that. Anyway, so this first one is coming from Crew 4. I showed this already, but this is the reflection of the crew with Artemis 1. This is the crew access arm on pad 39. So, like, Dragon is, like, right over there. This was no doubt during training or something. And they have SLS out the window, and the reflection of the crew is in it. That's actually a really cool picture. Yeah, it's pretty sweet. It does. Thank you, my friend. Right on, man. Cool. Yeah, reps. Climb and maintain 2,000. Yeah, that's not how that works, right? Flyover and the Buka update. Yeah, Boca Buka. Let's go. All right, cool. Let's jump through the rest of the space news, Lassie, and then we will jump into that. Oh, nice. There's a KSC update for NSF. That's sick. Those are my favorite, dude. Those are quickly becoming my favorite. Let's see. So this is coming from Mary down at Boca Chica here. Boca Chica. That's really nice. That's really nice. Yeah, I really appreciate this Ferd right here. Oh, that's really, dude, look at that. That's a nice brand new super. I'm just kidding. The motors though, and also that. Speaking of shuttle landings, I had never seen this landing before. Ouch. Is that the That's not real. That footage is not real. Tech, this footage is fake. Well, guys, I'll let you know. I've climbed Mount Everest once, so, you know, I can land a space shuttle. Anyway. Okay, Lunprod, I got it. Wait until you see the cave. Hopefully they show it. Related. Oh. Yeah, so those are 3 Raptor 2s being delivered. And... no way! No way! No. That's photoshopped on there. No way. Yes! Awesome! That's, you know, someone at SpaceX is like, huh, kind of looks, top of this kind of looks like a Lego head. Alright. Cool. That's awesome. These should be emotes? I don't know if Lego would be too happy about that. Oh yeah, you could kind of see it right there. That's cool. Yeah. But I think this picture is really cool. Were you paying attention? Or were you staring at the nice pickup truck? Look again. Should be up to 7 Raptor 2s on site. Bad, EJ, but what? This picture is cooler. Oh, look, the helicopters that NASA should be using. Huh, that's nice, Thomas. Yeah, that picture's pretty sick. That's pretty sick, Chubbs. Orange rocket, good. What's this picture? Day 129 of Cursed Rocket Photoshop. Saturn Hey! Wait a minute! I talked about this yesterday on stream! Who are you? Where are... Which one of you did this? Which one of you controls this account? I talked about doing this on stream yesterday! What the frick? That was... This is my idea, Cursed Rocket Man. I literally said this yesterday. I like it. I like it. I really like it. That would actually be really cool. Or this? Is that the... That's really cursed. No, okay, no, hear me out though. Hear me out though. Hear me out. Take this, right? Just with the three landing engines, right? Take a Starship. Make the whole Starship fuel, okay? And then make the header tanks go to the 3 landing engines. Okay? Still with me? Put that right there instead. SRBs on the side of a Starship tanker variant with its landing engines, but the main fuel tanks are hooked up to the shuttle engines, right? Right? And then the header tanks inside a Starship are hooked up to the Starship engines. So you fly up, the SRBs separate, they come back down, they parachute, you go fish them out. All right? And then the shuttle jettisons Starship. Starship comes back down, uses the header tanks to land, lands next to the pad, and then the shuttle, after a couple of days, comes back down, and it lands on the runway. Thank me later. Thank me later. Yep. Yep. Thank me later. Anyway, next bit of news here. Let's see, what do we got? That's tomorrow's photo then. Did we just become best friends? Did you just open a startup? Yep. SpaceX version of the helicopter picture. Yeah, that's cool. Yeah, one of the Blackhawks though is turning. All right. Try this one on for size. I retweeted this one. I retweeted this one, Creeper, saying, I secretly want this. I'm not gonna lie to you. I really, really want it secretly. Actually, I wanted the lunar lander, Starship HLS, up here. Not the Flappy Boy Starship. It took me too long to notice what was wrong with that photo. Yeah. Just to use 2 Falcon 9s instead of SRBs? Burbs, you could, but the problem with that is that Falcon 9s do not make enough thrust. Those 5-segment SRBs make 14,000 kilonewtons of thrust. Falcon 9 makes 10. You would need 4 of them. And they would need to be Falcon Heavy side boosters. Okay. Moving on. Moving on. This is good. Sorry. Hey, you said something earlier about Skylon being underdeveloped. Are the Brits finally going to get something flight-worthy again soon? King, interesting thing with Skylon. So first of all, Boeing and Lockheed both invested in reaction engines, and Skylon is testing things out in Colorado, from what I understand. Yeah, it's some weird stuff. Yeah, so Boeing and Lockheed have their hands in that pie. And they're using it to do... So, yeah, I'm not exactly sure what's going on, but if we look at Colorado, outside of Denver, there's a very indescript airport right here. They're doing tests out at this airport. It's very weird because it's just this weird kind of general aviation airport that's out in the middle of nowhere, and they're doing testing on the Sabre engine here. I've seen like newer renders here and there of different things, of like different concepts for the Sabre engine, but nothing so far with like Skylon. I haven't heard much about Skylon development. This is, like I said, it's a very strange airport. Like, this airport has this weird taxiway that goes over here, and you have a runway threshold indicator there, but this runway is very, yeah, it's very strange. It's a very weird runway just to be out in the middle of nowhere. So we got 8 hash marks, so it's 100 feet. You see the hashes? It's 100 feet, and it has, there's the wind. No ILS from what I can see. I don't see any localizers on this runway either. But yeah, this is the runway that they're using. Oh, it looks like there's a VOR. Oh, no, that's just the water tower. Or is it? Yes. See, something weird. Something. Not weird. It's just, yeah. Like, what is this? This looks like, actually, you know what this looks like? This looks like a ex-military base. I don't know. King, maybe. So they're doing something. Oh yeah, Axiom. Hey, what better late than never. Those are precision runway markers that should have ILS. Let me see. Do we see a localizer? Is there... Oh, bingo. Yeah. Where's the localizer? Where's the beef? It looks like there was a localizer there. Not anymore, though. But... What is this? Huh. And it's like right next to, it's right next to Denver International. Huh. Okay. Colorado Air and Spaceport. Oh, no, not Airbnb. Nice. Formerly known as Front Range Airport, is a public airport in an unincorporated Adams County, Colorado. Nice plane. Front Range Airport opened in 1984 when the now demolished Stapleton Airport was the major air hub for the Denver Metro. Until 2005, it was non-towered without air traffic control surfaces when the tallest general aviation control tower in the United States was opened along with full ATC services. After 19 years as airport director, Dennis Heap and the airport board parted ways in August 2013. Heap was replaced in late spring by Dave Ruppel. And the airport was originally owned by the Front Range Airport Authority, continuing until January 1st, 2014, when the FRA was dissolved and the airport and all employees were folded into Adams County government as a departure. Since then, the airport has seen a marked improvement in general aviation, air taxi, military traffic, as well as other air-based ventures, such as the helicopter-based business of Air Methods. Yeah, see? In December 2017, the British aerospace company Reaction Engines began constructing a test facility at the airport for the development of the Sabre engine. That's literally the last time we heard pretty much anything about that. Yeah, it's kind of weird, but whatever. The reflection thing we already got. Okay, so... King, I don't say anything on this stream that violates ITAR. I'm very, very, very careful with that. Very careful. More info about it. Oh, there you go. At Gaw. Stop hitting your enter button too early. You do that all the time. Dropping on July 1st, F1 2022 got announced today, and it looks clean. Alright, let's see what we got. Then we'll get Lucy news after that. Stop linking cursed rocket photos. Stop doing that. Neubauer, stop making that noise. No approaches for from the west for obvious reasons, and sorry. Dude, I'm just kidding. Don't worry about it, man. VR, huh? This game will also be played on VR. F1 esports about to go to the next level. Oh. Have you ever dated doing a Freedom of Information Act request on yourself to see if they know who you are? I don't need to Freedom of Information Act that, King. Ever tell you about the time I showed up at Edwards Air Force Base and they knew who I was? I was in the system already. True story. Yeah. We, Doom Machine in chat helped me set up a thing with Armstrong Flight Research Center, and we had to go through Edwards Air Force Base to get to it because it's on Edwards Air Force Base. We showed up at the booth, right? And I gave them my name, and they're like, okay, give us your names to put in the system. I gave them, I said, oh, Eric Johnson. And they go, oh, yeah, you're already in the system. I'm like, what? What? No, it turns out that I didn't know. It's not like I was in the system because in order to get on Kennedy Space Center and like walk on the mobile launcher, I needed to be in the system to get range clearance because the type of tour that I got at Kennedy in 2015 is not, that ain't no National Social tour, you know what I'm saying? So whatever database that they use for the range in Cape Canaveral clearly works across most military bases. So like I said, I'm not saying that I have any business on any military base ever, but if I went to the booth, I could say my name and they would know who I am. They just would be wondering why the frick I'm there. You know? Yeah, it's definitely government-wide, considering I was entered into that system in Florida and then showed up at an Air Force base in California for a tour because my presence was requested and they knew who I was. So there you go. The guy was like, okay, that's your name? Oh, you're already in the system. Boop, here's your pass. I'm like, what the hell? Yeah, it was a little strange. It's called D-Bids now and I had to go through it. Yep. It was actually just sir, this is a Wendy's. But F1 does look good, though. Huh. So when you walk up and try to order a cheeseburger. Oh, God gifted a sub to FBI van number 50266. 2017, Thomas. Yep. Everyone's on a list. Of course we are. Dude, come on. This stream with what we talk about, there's no way. There's no way that somewhere in the Department of Defense, other than, you know, the registry like that somebody doesn't know about what I'm doing. There's no chance in hell that that's not a thing. Like, like, let's think about that logically for a second. Open up! Yeah, right. I guess EA is making it now, not Codemasters. Interesting. That's cool that it's going to have VR. I would say, are you guys interested in doing an F1 campaign in VR? Because I have a VR headset, but I know the answer is going to be yes, so I guess I'm going to have to buy that game when it comes out on the 1st, huh? Yep. Okay. EA is the publisher. Codemasters still made the game. Sweet. Yeah. Yeah, we got to do some pretty cool things on that tour. Yeah, like that. Yeah, there you go, Thomas. On that day, I learned that I am way too tall to fit in an F-15. Yep. Oh yeah, Primo as well. Yeah, Primo. Yeah, Primo as well. Primo sat in an F-15. Have you sat in an F-15? Don't think so. Cool story about that F-15. That's like F-15 serial number 3. It's one of the oldest F-15s that still flies, and it was leftover, so like most leftovers from the DoD, NASA got it. Yep. Yeah, Geezer, my knees are touching the dashboard, so to speak. Yeah, be like me trying to fit in a classic Mini. It's just not gonna work. That ain't gonna work that way. Very old racers like F4, A6. Those are nice. Those are nice. F15 is faster. Just saying. I mean, and I'm an F4 fan. F4 is my favorite because, you know what? Speed. That's why. Another angle. Yeah. Yeah, okay. Look at my knees in this picture. Yeah. Okay. I did, DJ, yeah. Archie's like, I've been sitting in an F-18 for 8 years. How tall are you? Metric or Imperial? Finnish Air Force? Hell yeah, Artsy. Have a pivy. You're 172 centimeters? Oh, man. I got 20 centimeters on you, boy. I'm 6'4". Alleviate, yeah. I don't, like, talk about that, like, on the day. I don't advertise it, you know. That's why I'm flying and you're not. Ugh, you got me there. Well, all right. Yeah, that's fair. Artsy, that's fair. Yep. Would you fit in upgraded Skyhawks, huh? I don't know, but that's kind of cool. Modernized A4s. I want to test hops in a T-38. Nice, Racer. That's cool. Falcon 9 in flight with Dragon on the pad. As if I didn't have that picture. So this is from a picture from the Starlink launch via SpaceX. Actually, Elon posted this. You know what? I'm just going to go right and say it. That picture is pretty freaking cool. Yep. It's from NASA. Oh, even better. Oh, we got another one from NASA. Dude. That's pretty cool. That's pretty neat. That's pretty neat. This just happened. JSX is proud to be the first air carrier to adopt Starlink in flight. Oh, that's cool. Wow. Yeah. Where do we file this, fellas? Is it SLS? Falcon or all of them? All right. There we go. Done. You need a glory shots folder. The pic Elon posted is from Ben Cooper. Oh, okay. Yeah, Elon's doing that picture thing again. Okay, got it. Thank you for giving credit, Thomas, because I wasn't sure. Yeah, it's my home. Yeah, Penta, it's my homework folder. Yeah. Yeah, homework folder. So, 39B, 39A, Slick 41, Slick 40, and then the way back over there, 37B. I would just like to remind everybody that every one of the pads that I just mentioned is active. Yeah. 39A, 39B, 40, 41, 37B. All active pads. Yeah, and on top of that, all right, so if you really want to know, there's a Delta 4. There's a Delta 4 Heavy in this one. I'm pretty dang sure. Pad 40 has another Falcon 9 with Starlink teed up. This one launched today. There's another one set to go off in a week. 41 has the OFT-2 core inside of the VIF. We saw that put together yesterday. So they have an LVOS on their mobile launcher, meaning there's an Atlas V on 41, in pieces though. 39A has the Crew 4 Dragon with Dragon Freedom, and then 39B has SLS with the Artemis 1 mission. You know, I might be a little bit salty about Constellation getting canceled from time to time, but you know, this isn't bad, right? Like, you know, it sucks that it got canceled. I'm a little annoyed about that because it's not that it sucks right now, but that it could be better. But also, this is not bad. I will straight up admit that. Yeah, I will concede that immediately. This is pretty cool. I like what's going on here. Yeah, I really appreciate this. Well, to be fair, this picture is only 12 years late and compared to Constellation. I will always argue in favor of more rockets, rocket guy. I really don't care what excuses people have to the contrary. But yeah, it's a little late, and that, yeah. I mean, because, like, see, okay, we didn't have, if Constellation didn't get axed, there would be an Ares 1 right here on a mobile launcher. There would be an Ares 5 right here on a mobile launcher getting ready for its first test flight. And then Slick 40 would be a twin pad complex with one Falcon on the crew part of Slick 40, and then another Falcon on the cargo part of Slick 40. Yeah. SpaceX, before they got 39A, what they wanted to do was make Pad 40 a twin pad complex. They would have, here. I'll show you. There are plans that were floating around on NASA spaceflight from a long time ago. Like a decade ago at this point. What SpaceX wanted to do was make another Falcon pad right here. That was a long time ago. They wanted to put basically another one of these right here and then have the HIF for the building right here. So the Slick 40 was going to be a twin pad complex. Kind of similar to how what they're doing with 39A, how it has a Starship and a Falcon pad on it. And the Falcon pad, or the Starship pad's kind of off to the side. They wanted to do that here for Falcon Heavy launches. So they would have had twin Falcon pads right here. In some universe, that exists. So in some universe, there's two Falcon 9s right here and here. There's an Ares 1 right here, and then there's an Ares 5 right here. And there's also Atlas and Starliner, and there's also Delta IV Heavy. In some universe. Not ours, though. So old 36. Kind of like that, goalie. I mean, SpaceX, that was a preliminary plan, but I'm fairly confident they probably would have ended up buying another pad somewhere. I don't know if it would have been 36 or what, but yeah, that's what I mean. This is pretty good. I don't mind this. This is fine. Like, but it could be better. It could be better. It almost was. But this is also really nice. I like this. This is, we just keep doing this. That's fine. Oh yeah, Thomas, you found it. Here, I'll show you. Yeah, that's what they wanted to do. Yeah, see? Twin pad complex. If you remember that YouTuber who crashed his plane in December, the FAA has concluded that it was done on purpose. What an idiot. Oh my gosh. What a moron. What are you doing? I had my suspicions, guys. Nobody goes on a regular plane flight with a parachute, believe it or not. That's just should have been a pretty damn clear indicator. Frick that guy though, for real. No, I'm with you. What an idiot. Like, how could you do that over a national forest? You know there's people down there, right? What are you, dense? What the hell's the matter with you? Yeah, see, there you go. That's what it would have looked like. Look at this awesome thing. It's an RL-10. Yeah, those are cool. Yeah, see? That's what they wanted to do for Falcon Heavy. Which tells me that they would have, converted this for crew use and probably built a crew access arm like Pad 41, like that thing right there. See the upside down Tetris piece right there behind the water tower? Yeah, Creeper. Also wildfires. What a doofus. Dude, I could just sit there like, okay, right? I talked to an airline pilot that I know. The guy, he doesn't want his name going out there. But after that happened, I showed that dude that video, and he looked at it and said, you know, I can't really say one way or the other, but also at the same time, who carries a parachute? And just no pilot, and I know this from KSP, you know, from playing KSP. I'm not going to say that KSP will teach you how to fly a plane. That's not the implication that I'm making. It will absolutely not. You need to go to flight school to learn this stuff. Simple as that. Straightforward, done. Right? One of the first things as a pilot, if your plane goes wrong, if something goes wrong with your plane, the first thought isn't to jump out, I'm good, especially if you're up at like 10,000 feet. You could be 100 feet off the ground and it's still not, oh, jump out. No pilot is ever taught to do that. It's not a freaking fighter jet, you know? It's not a fighter jet. You just don't do that. The guy had an engine failure at 10,000 feet and an engine failure at 10,000 feet, and his first thought was to just jump out of the plane. No distress call, no attempt to restart the engine, no attempt to glide it down. That is, dude, should be in jail. That guy should be in jail. No joke. Didn't even broadcast, didn't radio that he was going down. Mayday, made it. None of that. Nope, nothing. Just, oh, my engine stalled. Bye. What is this, an action movie? What are you, stupid? You could have gotten yourself or somebody else killed. Yeah, sister. No, I know. And he jumped with a selfie stick in his hand in a parachute. What a doofus. Yeah, welcome to YouTube's freaking phone sister. Anyway. Yeah, Metroid. Yeah, the FAA rescinded his pilot's license. Dude, you're never flying a plane ever again. Like, what? Yeah, exactly. He's at 10,000 feet, Artsy. What a doofus. Anybody that knows anything about planes would immediately be like, no. That's not, dude, that's not how that works. Heck, Artsy, if your plane gets hit with AAA, right, you don't eject. You eject when you're 100% sure that the plane will not be able to land, right? That's what they teach you. I mean, you know that, right? Ejecting from the plane is dumb. That's really stupid unless you absolutely 100% can't do it. He can reapply after 1 year. Oh my god. They had plenty of footage to review when revoking his license. What an idiot. Oh my goodness. Hey, Arendalario. AJ, I saw Falcon 9's second stage deorbit and burn up, and Starlink satellites near it after launch from Spain. That was cool. Right on. That's awesome, man. Oh, jeez. Self-report. What do you do? Wow. What the things people will do for YouTube clout. And you know what the crazy thing is? Okay, two crazy things here. Thomas, I'll check that in a second. Two crazy things here. One, those planes aren't exactly cheap. How much would that, what was it, a Piper or something? How much would one of those things run you? 50, 60 G's? Like, how much is that going to run you? It's going to run you a lot of money, right? And that leads me to the second part. You know what's messed up? He probably made that back. He probably easily made that back. Do planes have insurance? Of course. That's the second messed up part. I'll bet you he made the money back off ad revenue and stuff. I bet you easily made over 60 G's. I don't know what to think of that. YouTube allows a market to exist where crashing planes on purpose is a profitable venture. And you know what the screwed up part about this is? If he had said what he was going to do and announced the intentions and applied for like a TFR and stuff, it probably would have been fine. You could probably do it. It probably would have cost more money, but also at the same time, you don't lose your pilot's license. $1.8 million views. Oh, he made that back and then some, Alleviate. Isn't that messed up? That's so messed up, dude. That's so messed up. About 13K? Really? That's it? That's all for a plane like that? 13K. Oh, jeez. Wow. He's way in the green on that. I mean, when he bought the plane, he told the guy he had big plans for it. It was a 1940s Taylor craft. But if you play 0.0001 seconds of any song, you get DMCA'd. I don't know, Alex. I don't know. It was cheaper because it was not in flight-worthy condition. He was not supposed to be flying it. Oh my god, what an idiot. Dude, what are you doing? What are you doing? And you know, I recognize that airport. I recognize the airport he took off from in that video. I know exactly where that airport is. It's Lompoc City Airport. I drove by it during Route 154. Yep. He took off, and then he flew up to 10,000 feet, and then he bailed over here in the mountains over here. Literally 10,000 feet with a plane like that out in the mountains, and there's like 20 different airports right here in this valley. Like, you could literally see them. Dude, you could just glide. You could just glide over to another runway. That was my big thing. Pilots don't just bail out of planes. You know, oh, the engine failed. All right, cool. Bye. Yeah, no, it's really, really stupid. With a full skydiving rig. Yeah, I know. Dude, how did... You know, like, Kurlani, maybe the guy did it on purpose. Maybe he did it on purpose. You know, maybe... Maybe he wholly knew the consequences of his actions, and, you know, maybe David said, screw it. I'll make more money off of this than having a pilot's license.
Discovery, go at throttle up.
Hey, Vittergoltz. Welcome to Mission Control. You go at throttle up. Thanks, buddy. With that plane, a road would be good today. Yeah, it's practically a bush plane. Unbelievable. It's very strange to me. Anyway, while we're on Google Earth, guys, I thought I'd show you this. Somebody just mentioned it to me in chat, but check that out. The images aren't the best, but looks like Google Earth updated Boca Chica. The plane is like paper, it could land anywhere. Yeah. Stupid. Stupid. However, that's not stupid. Oh, look at that. That's pretty neat. Well, that's pretty neat. You can tell it's a starship because of the way it is. And that's pretty neat. Oh, that's sick, man. Maxer with the W. Man, they're making all kinds of cash, man. Maxer's making all kinds of money. They're making all kinds of money imaging other places, but they're making all kinds of money. Is it in Australia? Yes, because it's upside down. Yeah, Kev, I don't know how I feel about that. I mean, that's what I mean. He must have known. That guy must have known that that was going to happen. All right, fine. I just won't fly for a year. Whatever. He must have known. He had to. There's no way he didn't. Though in that regard, yeah, like I said, the guy probably made his money back and then some. 1.8 million views. 1.8 million views on YouTube is good for some cash. Maxer also has the power and propulsion element for Gateway. They do. Yeah. Of course, Axiom. Yep. Probably calculated the risk. Yeah, I mean. Yeah. I wonder if he can be fined for the cleanup. Yeah. I don't know. Yeah, I'm not sure. Anyway, to quickly go back to SpaceX, in 2007 there were... Oh yeah, that was your comment, Thomas. What did you say? To quickly go back to SpaceX, in 2007 there were also plans to launch Falcon 1 from the Cape. Plans also mentioned Slick 36 as a possible Falcon operations, as well as Slick 47. Yeah, God, maybe. I don't know. Yeah, either way, great pictures and interesting stuff with the pad. Yeah, Slick 36. If I recall correctly, Thomas, Blue Origin wanted pad 39A for New Glenn. They wanted 39A for New Glenn, and when the contract was awarded to SpaceX for the launch pad, Blue Origin, take a guess, put in a filing in the Court of Federal Claims. Yep. Yeah, they said that they were I don't know, they said that they weren't awarded the pad. The circumstances in which SpaceX was awarded the pad was, I don't know, I forget what they were trying to say. They said, I'd have to go read the contract. It's been a while since since I went and read what the injunction was. How's Blue doing, by the way? They're all right. I'll be honest, fellas, after the national team, like the HLS contract not getting awarded and the national team and stuff, Blue has been really diversifying their contracts. They have a little bit of their fingers in all kinds of things. Anything from what I understand, I don't know if this is true or not, like nuclear propulsion, other types of landers, maybe even reusable second stages. I don't know. Yeah, and if they did get it, you wouldn't see a launch from it in another 15 years. Yeah. I'm glad Blue didn't get it. They would have totally rebuilt it with no regard for historical significance. Yeah, you don't know that for sure. Look, actually, Creeper, if you really want to know, I have this thing. I have this thing about 39A. And my thing about 39A is that, well, okay. I should precurse this with saying that I'm not a SpaceX hater by any means. No way. No way. Not a chance. I love everything that they do, and I'm fine with what is going on right now. It's better than nothing. I know that. Everybody knows that. That's not really the point that I'm trying to make. It is kind of annoying that we wasted a super heavy launch pad on a heavy launch vehicle. Meaning that 39A, putting Falcon on 39A is cool. Like, I don't have a problem with it. But I can't help but think in the back of my mind that disrupting the crawler way, NASA putting out, getting this, basically leasing the pad to SpaceX for the long term, right, is, I think that was a really short-sighted thing for them to do, to be honest, because SpaceX built the HIF right there. They built it right on the crawler way, and now you can't get a crawler into 39A. So you lost some capability. 39A is a super heavy launch pad. It's designed to launch like Nova and Saturn rockets and SLS and Ares style rockets or something like the space shuttle. Falcon Heavy, yeah, you could make the argument that Falcon Heavy is, more like in line, but I think that NASA giving up that capability to have two launch pads with access to the VAB was an incredibly short-sighted decision. That was really foolish. So would you have left 39A alone for a decade? Not a great plan. See, Doxy, I think that was a short-sighted decision. However, and this is what I mean. No, I wouldn't have. Giving it to SpaceX is better than nothing. Because if they didn't sell it to SpaceX, Pad 39A would literally be abandoned right now. And that's what it was. From 2011 to 2015, after the last shuttle flight, they abandoned it in place. It was AIP. Just leave it. And it killed me to see that thing abandoned. It really hurt. The pad that we first went to the moon from, sitting and rusting away. It's really annoying. Well, that Blue Origin tried to.com, but I think that's a little bit on the short-sighted side of things because NASA spent all that money refurbishing 39B and retooling the VAB and the high bay, and them not having 2 pads makes it so you have to have a tremendously high stopgap between launches because you have to build a new ML and you have to redo the pad every time you want to upgrade the vehicle. Having 2 pads meaning, so like, okay, let me put it to you like this, Balg. And once again, I know good and well that there was no money for this. I understand, right? And the real reason why SpaceX has 39A is because, well, hey, guess what it goes back to? Constellation getting canceled. Oh, geez, big surprise, right? I know. So, like, with SLS, you have Block 1. You retool 39B and its mobile launcher for Block 1. And then you work on 39A and another mobile launcher for Block 2. And instead of basically working on Block 1, launching Block 1, and then working on Block 2, and then launching Block 2, or Block 1A, right? Or Block 1B, you can have overlap. If you have overlap in the design, you get a higher launch cadence. But, nope, we can't do that. That makes too much sense now, doesn't it? But, so, I will say this. It is kind of sucky that SpaceX blocked the damn crawler way. That sucks. But it's better than the pad being freaking abandoned. Yeah, you basically hit the nail on the head before I could say it. It's annoying seeing, a pad not have access to the crawler way. That's really annoying, but also at the same time, I'd rather it be used than it not be, So, it is what it is. I mean, maybe if Blue got it or something, they would have utilized the VAB and utilized the crawler for New Glenn. That would have been pretty neat. That would have been kind of cool. But also at the same time, who knows what Blue would be doing? The pad would be just sitting there refurbished, and then that's it. It still wouldn't be doing anything, What's the future of the Vasmir plasma engine? Any hope? I don't know. In good time. NASA's working on nuclear propulsion right now, Karvik. So, yeah. I mean, the other thing is like, it'd be really nice if Starship could utilize 39A proper instead of just the pad that's sitting right next to it. But then again, how can SpaceX stop take 39A out of operation? What are you, crazy? No way. Apparently there were some plans where Blue would use it together with ULA using mobile launchers in the VAB. Yeah, that would have been nice. But, we talked about this yesterday with Tidris, and we talked about it once, talked about it again. It's really kind of annoying. I don't like how NASA tries to, I don't like how NASA gets off on trying to make KSC a multi-user spaceport. Like, oh, it's a multi-user spaceport. It's a multi-user spaceport. And then they sell off all of NASA's stuff. They pawn off all of NASA's facilities to commercial contractors. Like, and don't get me wrong, once again, not trying to start any beef with SpaceX or anything. Like, it's not their fault NASA sold them the stupid pad, Like, yeah. It just seems, I don't know. I'm not going to say that it doesn't seem right, because once again, I'd rather see the pad work than not. It just, I've never sat right with NASA, oh, let's just give away these pads that we need. Oh, we only have one pad. Oh, the development of the rocket is going to be over a 10-year period to get even a baseline architecture. And part of the reason is because we only have one pad. Like, okay. Weird question. Are there remnants of the original 39C? The only thing with 39C that ever existed is this. The extension piece to the crawlerway. The Apollo program anticipated scales, eh? They anticipated scale, so they built the infrastructure to be able to build the crawlerway out for another pad. They never did, but it is what it is. Yeah. How much work is it making a new pad around here? You gotta move a lot of dirt, Sile, because of flooding and drainage and stuff. Florida's pretty wet. And anytime you do something with rockets, it's usually, especially big rockets like this, it's usually heavy, and you got to be careful with that in wet terrain. Man, I wish space saw 10% of Department of Defense spending. King, you know what the messed up part of that? The messed up part of that is that if NASA's budget was doubled, they could build 4 pads and operate something like Constellation and the Commercial Crew Program and the Science Mission Directorate and then some. The truth of the matter is that space flights may seem expensive to you or me. It's not expensive to, I would say to the taxpayer, but it's not expensive for Uncle Sam. It really isn't. And frankly, I think there's really no excuse. There's no excuse for that NASA doesn't have more money, because, like, the positive benefits, and don't get me wrong, the same logic can be applied to defense spending, whether you like it or not. It can. What's annoying is that NASA can create so many freaking jobs. It can create so many jobs. So when I think the net return on every tax dollar spent on NASA is like tenfold or something. Meaning all these NASA space centers employ a lot of people, and all those people pay taxes, and then you could basically have an entire city. Like, it's such a boost to the local economy having all these engineers here, you know? Anything from like having more restaurants in your district, to having a car dealership, to having, you know, a grocery store. Like, everything gets boosted from having these NASA facilities in here. And then there's that whole, you know, thing that you do, that NASA does, like generating really awesome science. You know, that's a benefit. So there's really no downside to it. You know, there really isn't much of a downside. And once again, you think NASA facilities are good? Military bases really boost the local economy, because that's a lot of stuff. That's a lot of people. Like, the same logic can be applied to defense spending. But if that's the case, like I said, there's just no excuse. Like, if NASA's budget was double what it is now, if we doubled the Science Mission Directorate and Human Exploration Operations Mission Directorate, we could literally do everything that we talk about on this stream and probably have money left over. Okay, Fun Sister. Well, King, I don't think that, personally, this is EJ's personal opinion here, I don't think that making the argument that defense spending is useless is a really wise decision in this day and age, especially given current events, but hey, whatever. Anyway, let's move on to the next news. Let's get that Starship update. How about speaking of KSC and its pads, we watched NASA Spaceflight's NSF's video about pads, about what's going on down the Cape. I think this video might be brought to you by Squared Space. I'm not sure though. Who's narrating today?
This video is sponsored by Squarespace. This week,
Ian.
Starship's factory begins rising from the Florida swamp, and we're seeing some serious groundwork for Starship's launch tower and pad at 39A, which will be used to launch SpaceX's Mega Moon rocket. Hey everyone, I'm Ian Atkinson with NASA Spaceflight, and welcome to this week's flyover of all things going on at Cape Canaveral, including an update on the Blue Origin facilities and future plans at the world's most famous spaceport. First, let's dig into what's happening over at Roberts Road. On the east side, Hangar X is seeing more work at the future delivery area. A new fence is now splitting the area into 2 parts, one of which is believed to be for fairing half delivery and refurbishment, as well as the rollout of those fairing halves once refurbishment is complete.
Hold on, Zay. Nope, Zay, I'm gonna stop you right there. You do not talk about that freaking parking lot outside of 39B. That does not deserve to be a complex. That never was a launch complex. That was a stupid idea, and we do not talk about that pad in here. No. That pad does not exist, okay? You don't take a parking lot and say, "Oh, it's a launch pad now, guys, I swear." And hey, anybody want to use my launch pad? No. No one wants to see your pod collection, NASA. Go away. It's a parking lot. I could show it to you on Google Earth. They took a parking lot and kind of paved some concrete in a way that maybe looked like a pad at some point, and then said, "Hey, look, 39C. 39 is a 3 launch pad launch complex." No, that's pathetic. No. Bad. The only people that can call a parking lot of launch complex is Astra, all right? They're the only people that can do that because they could set up their shop in a launch. They could set up a launch pad in a parking lot and launch from there. Boom, roasted. We do not mention that pad. We do not talk about that pad. That is a low point. Bad. Bad. No, you want 39C, build a copy of 39B a little ways north and build the crawler way to it. That's 39C, but no, we can't do that, can we? No, we gotta make a stupid freaking parking lot. I'm not bitter about this at all. I don't know if you knew.
As for the other side of the delivery area, this is most likely going to be used as a general delivery ramp, as these delivery spots are already being used, with a SpaceX van parked at them.
SpaceX van.
Next to the east facade of the hangar, a few trucks are lined up with what appears to be more material for the interior of the hangar extension.
That's the market they were trying to anticipate. The problem with all right. That was just an act. I'm actually not too incredibly mad about this. There are things to be more pissed off about in the space program if you're going to be pissed about something, okay? We'll get back to Ian's video in a second. The reality of that situation is that NASA, no one took the contract because NASA was trying to compete with the Air Force in terms of buying and leasing launch pads, right? Now, King, just as a little bit of a continuation to what we were talking about earlier, how many launch pads do you think the Air Force has at Cape Canaveral Space Force Station? Go ahead. They know. Go ahead. Just say it. It's way more than NASA. And these are like facilities that were not for a small sat launcher either. Long story short, NASA tried to compete with the Air Force on selling launch pad real estate. No. 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 Not even close. Nice, Sebby, that's good. The Air Force has tons of pads left over from Titan, Atlas, Delta, missile testing. There's still probably, let's see, let me tally it up in my head. There's still got to be 8 or 9 launch complexes at the very least that could be leased. At the very least that could be leased? At the very least that could be leased right now for a small to medium duty rocket. So like we're talking something like Intari sized or smaller. You can't compete with that. Which furthers my point that building more pads is better because price go down. Why use more pads when more do trick? What's that, Kentab? Nice. Yeah, there's tons of launch pads. That's why 39C was stupid. There's no point in competing with that. You get a parking lot on the side of a pad that NASA already uses, or you get a former Atlas missile complex, right? That has the commodities and the industrial power, and it's your own pad to launch something that could easily get up to like Falcon 9 size. Like why the heck would you even consider the stupid parking lot? The funny thing is, King, is that Astra didn't even consider that. Astra themselves said, let's launch from LC-46. It's because it's cheaper. Why would we launch at 39B when we could launch at LC-46 and we could have the pad to ourselves? Oh. It doesn't make any sense. Now that Space Force exists, does the Air Force have any space stuff anymore? There's some here and there, King, but most of it was moved to Space Force. And once again, I said this when Space Force came out. I said I'll say it now. It's not anything that we haven't already been doing. It's just they consolidated it into its own thing. There's no increased regulations here with Space Force. Just like the Army Air Corps was basically the Air Force, or the Air Force is basically the Army Air Corps with a different name and a couple of different capabilities here and there, but it's more or less the same thing. They changed it because, like how after World War II, air power became a very, very quintessential piece of war that deserved its own branch of the military. The spaceflight market, they marketed it as the war in space is increasing, but the more people are launching more things into space, so that warrants more controls. Like, more, you need more people, like space control squadrons, watching all the stuff up there. You know what I mean? So, yeah, that's why they did it, because space is an evolving market. You know what I mean? It's believe it or not, it's more for the commercial side of things. And you could say whatever you want. Like, you can go look at Space Force's doctrine. It's right there in plain English. Space situational awareness and space debris management. They're basically a coast guard for space. That's it. Yeah, nothing more. I think I look a bit silly, but it's all the same stuff y'all have been doing. That's what we do, King. Keep everybody safe, man. You don't want to get hit with falling debris. You don't want to get Donnie Darko'd, do you? I don't want to. Yeah, W, nice. Yeah. Also, I will just go outright and say it, that the camo that they wear in the Space Force show is better than Space Force's actual camo. Yep. You can hate me for that. That's fair. And I know that there are Guardians that watch this stream. I'm sorry. The lunar camo is cool, man. That's really cool. Like, I like the Marpat as much as the next guy, but the lunar Marpat is pretty freaking cool, man. That's pretty cool. Just saying. Just putting it out there. Don't you dare, Zay. Don't you say that again. Don't you say that again. Don't you dare do that to me. Anyway, let's back up a little bit and
delivery area. This is most likely
watch
going
the
to be
video.
used as
I
a
won't
general
interrupt it
delivery
again.
ramp, as these delivery spots are
Nice,
already
Airborne.
being
That's
used,
cool.
with a SpaceX van parked at them.
SpaceX van.
Next to the east facade of the hangar, a few trucks are lined up with what appears to be more material for the interior of the hangar extension. Additionally, the road to the north is getting paved in preparation to support the massive increase in activity at Roberts Road.
Yeah, that one
Not
I don't
only
understand.
for Falcon 9, but also for Starship. And speaking of Starship, to the west of Hangar X, we are also seeing more parts for future tower segments of the Cape Canaveral version of Mechazilla.
Yeah, they're burning
4
off the
of
brush.
these large tower segments have already been built, with the third and fourth segments getting parts for the central elevator truss, just like we saw last week for the first and second segments.
Yeah.
The feet for
Man,
the
that's
stand of
quick.
the fifth segment are already installed on the concrete squares, with a tower column sitting next to them, indicating that buildup of that segment is imminent. On the other set of concrete squares, we see preparations for the feet of the stand for the sixth tower segment.
5 ton.
In fact, these 4 feet over here are most likely the next ones to be used, and probably the ones that will go on to the sixth segment.
It's one right now,
Even
Paul,
further
but
to
it
the west,
should be more.
We see that construction of Starship's factory at the Kennedy Space Center is starting, with cutouts for the concrete spread footings clearly visible now. This is the place where SpaceX will eventually build Starship and Super Heavy parts, ranging from domes, barrels, nose cones, and much more. To the southeast of this factory, clearing continues in the area where the twin high bays for Starship and Super Heavy assembly at the Cape is expected. Based on plans published for the area, it is likely that these structures will resemble the second high bay at Boca Chica, also known as the Wide Bay. Right between this area and the factory, a new access road is being added, which will be fundamental to delivering and moving Starship and Super Heavy parts, and, perhaps, even roll out fully built ships and boosters. Finally, the retention pond to the west of the complex is now being filled with water. Let's move on from Roberts Road and look at the launch infrastructure at Cape Canaveral, including SpaceX activity at Pad 39A. But before that, over to my buddy Jack.
Thanks, Ian. Also, thanks to Squarespace for sponsoring this video. I may be good with a camera, but I am not a web designer. Squarespace makes it easy for even a novice like me to make a website that looks professional. Squarespace is an all-in-one platform for building
Orange
your
Grove
online presence or
Apatoxin.
business, with tons of easy-to-use features and super slick designs. With Squarespace, easy and what isn't? Head to squarespace.com for a free trial, and when you're ready to launch, go to squarespace.com/NASASpaceflight to save 10% off your first purchase of a website or domain. And thanks again to Squarespace for sponsoring this video. Back to you, Ian, my good duder.
Thanks, Jack. Over at 39A. Progress continues on the concrete base for the Starship launch and catch tower, with the first stage of concrete filling apparently complete. We also saw work on the 2 back walls of the tower, which will eventually hold the drawwork system for the tower arms, just like at Starbase. It appears that the panels that hold the concrete during cure have been removed, a sign that points to the first stage of concrete filling being complete, as crews now get ready for the second stage of the operation that will further raise the height of the tower base.
That thing's gonna pop up real
right
quick,
next to the
man.
Starship launch and catch tower will be the orbital launch mount, used for operational launches from Florida.
Should be right around here.
In our last flyover, the area around this work site seemed to have a lot of moved ground, and a gaping hole where the orbital launch mount will be. In this week's flyover, it seems that the foundations for the mount's 6 legs are being built up to ground level.
Yep.
A bit further to the south, a new white tent has gone up.
More
while
Elon
the frame
tents.
for a second tent can be seen next to it. To the north, at the former Apollo and Shuttle era hydrogen sphere area, workers could be seen upgrading the existing tank to support liquid methane storage. Over at the main ramp, we can see that the Falcon 9 and Falcon Heavy Transporter Erector, or TE, is now back inside the horizontal integration facility.
You know what? This video came out very recently. That information's already outdated. Crew 4 is rolled out. The Crew 4 Dragon is on the pad. When people do this, they lose my attention. And Solar, Jack likes to have some fun, man.
Here,
I like
over
it.
the
I
next
think
2
it's
days,
funny.
The Falcon 9
He's
rocket
alright.
and Crew Dragon Freedom for the NASA and ESA Crew
Ian
4
said it.
mission will be put through final tests. SpaceX aims to launch the mission shortly after completing the Axiom 1 crew flight, also to the International Space Station.
Hell yeah.
A different Falcon 9 rocket was also spotted rolling down to the pad. The Super Sooty booster is B1060-12 and was seen here already attached to its second stage.
We watched that rocket launch this morning.
Rocket is slated to launch the Starlink Group 4-14 mission from Space Launch Complex 40 at the adjacent Cape Canaveral Space Force Station.
Yep, we watched that
And
launch
speaking
already.
of rocket movements, let's hop on over to Pad 39B, where another rocket will be on the move soon. The Space Launch System rocket, or SLS, for the first Artemis mission is still at Pad 39B, but not for much longer. NASA will roll SLS back to the vehicle assembly building after 3 attempts to complete the wet dress rehearsal milestone.
Soon.
But that doesn't mean things are off. The wet dress rehearsal will still happen, but only after teams fix a valve on the interim cryogenic propulsion stage, which is SLS's upper stage, and fix a liquid hydrogen leak on the mobile launcher.
Yeah, the catch can.
Air Liquide, an outside supplier of gaseous nitrogen needed for SLS in large amounts, will also upgrade their facilities during this time to better support the Mega Moon rocket's needs. SLS will head back to the assembly building around Tuesday, April 26th, for a few weeks of work before rolling back out to the pad to complete the wet dress rehearsal. Hopefully. And now, from the north side of the Space Center to the south, where Blue Origin's warehouse expansion in the south part of their campus saw more work this week. The planned area for the chemical plant remains untouched so far, but we did see more work on the future manufacturing factory's footprint, just to the west of the existing large warehouse. Over at the 2CAT, we see cladding going up on the main structure as Blue Origin slowly finishes the first 2 levels of the building. Inside, the ground and various access levels are being prepared for the future second stage testing. The roof on both side structures is also installed, and we can see that the larger one has 2 floors inside of it. Next to the 2CAT, more parts are lined up for installation, including parts for the 3rd level of the building. During the flyover, the area seemed quite busy as we could see several cherry pickers and cranes at work. Over at their launch pad, LC-36, Blue Origin announced updated plans for New Glenn's launch area. As Harry Stranger posted on Twitter, the launch complex will now include an updated refurbishment facility, a test area, and camera towers, among other things to help prepare the facility for launch operations. Stay tuned for future updates on that launch complex as they make these plans into a reality. At the launch and landing facility, A fair amount of progress has been made since our last update on this site. One large retention pond has been completely filled, while 2 others are making good progress. This area is the first part of a large industrial expansion of the facility by Space Florida.
Cool.
You can also see NASA setting up an area for the arrival of the Crew 4 astronauts, who will be launching to the ISS in the coming days on board a Crew Dragon.
Yeah, that's where the shuttle main device was.
A shortfall of gravitas lies empty. Even as the youngest drone ship in SpaceX's fleet, it still shows some significant burn marks from the landing Falcon 9 boosters.
Coking.
Its next mission most likely will be the Crew 4 mission
Coking.
to try and catch booster 1067. And that's it for this week's flyover. Be sure to check out our other videos from SpaceX Boca Chica, where you can see first steps of the new structures for Starship construction.
Well, I think
similar
that's where
to
we're
what
going to go,
seeing
Ian.
at Roberts Road. Also remember to check out our shop and our website, and to give this video a like and comment to support us.
I will like and subscribe and hit that bell, and you should too. Yeah, look, coking. Anybody launch model rockets? Yeah, that's the same thing. It's just much bigger, because bigger rocket. Let's back this up. Let's go out here a little ways. So, it looks like how many segments do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, Thomas, I think they're gonna build the entire pad here and then send it, because they can't build it at 39A because they're launching stuff from there. So over here, these guys are burning off the topsoil, or the brush, I should say. That's what this is. That's what this is over here. They, when you clear it, there's a lot of trees and whatnot. You got to burn it off. That's what they're up to. There's your tower segments. See last, please. What are they gonna do with the SLF? Commercial strata launches, something like that. Yeah. Yep. Man, this thing is. It looks like they're gonna build all of this right now. They're gonna build all of that. Wait, what's that over there? Huh. They're gonna build all of this right now, and they're gonna. Looks like they're gonna complete the segments here and then send it in pieces down to 39A and assemble the tower between launches at 39A, which is pretty nuts. Yeah, that's pretty crazy. That's pretty nuts. Could those 3 squared be for visual positioning? Yeah, maybe. But yeah, see, yeah, look at all this. They have 2 jigs that were used at Boca Chica right there, and then they have a bunch of other ones here. These are is kind of the stand that you make these pieces on. Also, 5-ton. There's the burn pit. They're burning off all the brush that was here. Super Duty, 5-ton. Bulldozer. It's not a bulldozer, it's a front-end loader, I know. The 3 squares could be the next to the water tanker conduit boxes. Yeah, that sounds right. Yeah, King. So here they started digging out the supports for the pilings there. Fellas, my cousin is a geologist, and she actually told me a little bit about, I told her about the core samples here, and she said why they're doing what they're doing, which is actually pretty interesting. So the topsoil here, we looked at the core samples from the public record of the report of the building that they're making here, right? And the topsoil of this is dark sand. So that's just the ground, so it looks like kind of dirt, right? And then just below the topsoil is limestone, but it's limestone chunks, okay? And SpaceX, I'd noticed that SpaceX seemed to have been clearing. They cleared the topsoil, right? And then below those limestone chunks is just kind of regular sand, I guess, regular-ish sand. About as regular as sand can be. And I asked my cousin about that. Why would they clear why are they clearing the topsoil and stuff? Why did they clear out all the limestone? And what she was telling me is that, well, limestone is not very good to have in the ground when you're building something heavy. And I asked, well, why? Well, the type of limestone, so when they take core samples, if you have limestone, because limestone is very porous, right? Especially in chunks, right? It's very porous, and what happens is that it absorbs water, just like sand absorbs water. Limestone is very porous. It's not like almost sand, but because it's a very porous rock, it absorbs water and it oxidizes. It rusts because limestone is kind of just an amalgamation of a bunch of different things, right? And if there's iron oxide or iron ore in that limestone, and most of the time there is, it will rust. The ground will literally rust. I don't think I need to tell you why in a place where a high water table is, so soil that sees a lot of water that's made out of limestone is probably not good to build a freaking 30,000 square foot or 300,000 square foot building on, which is why they're clearing out the topsoil. That's why they're burning all of it off, and they pushed all of it off to the sides. So, yeah, I learned that the ground, you can literally build on rusty freaking ground. And if you build on rusty freaking ground, well, anybody that works on cars, what happens when it rusts too much? It deteriorates and then it cracks off, right? That'll literally happen if you compress this stuff. So they clear that topsoil, which is actually really cool. That's why this area where they build the factory is like kind of more sand-ish looking. And then all the limestone chunks and stuff were dumped somewhere else, and then all the dark topsoil was ground up and they burn off all the trees. Limestone also dissolves in slightly acidic rain, so it might dissipate over time as well. Yeah, Mondred, that's actually the other thing that she said. She said if there's some acid rain, then you're screwed. Your building will literally sink into the swamp. Even if you built it on, well, solid ground, right? You got to get rid of all that limestone, especially since it's near the surface. You've got to get rid of it. Mm-hmm. Ironically, guess what is under the asphalt of most roads? Yeah, I know. So what SpaceX did was, and what these builders did was, you can literally see that limestone layer right there. See the lighter layer around the retention pond? What they did was they dug a big freaking hole here to lower the water table and to build this on a mound, to build the whole factory kind of on a raised plateau, right? You can see it's raised comparatively to the soil around it, right? They dug out this retention pond and they used all that extra soil. After they ground the topsoil off, they used it to plane out the soil so it gave the building something solid to build on. And there might be some limestone chunks in that dirt, but they don't ever have to worry about it because the water is all going to go over here. It's not going to leak into that area as long as they get the drainage right. So, yeah, I thought that was really interesting, and, you know, it's really cool because, you know, you think like a geologist, oh, great, you just get to go play with dirt all day. And that's not entirely true. I said that to my cousin, and she said, no, not dirt, rocks, differences. And also, there is a need for this type of thing if a building is going to get built correctly, which I thought was really cool. She goes, archaeologists play with dirt. And I'm like, okay, yeah, that makes sense. It's actually really cool. The industrial application of geology is pretty sweet. I thought that was freaking cool. And you can see, look, see, the lighter sand is the good sand to build on. You can see that they're building out a heavy road right there. I wonder what that's for. But yeah, see, if you look at it from a certain angle here, right? Look at how much lower the ground off topsoil area is. See what I'm talking about? They ground all that off and they built the whole thing up on a plateau. This is like natural ground height right here. And they built it all up so the water wouldn't leak into it. Like, look at the height difference right there. It's a pretty long way down. It's like 15 feet, or about 5 meter difference right there between the ground right here and the ground that the truck is on. That's a big difference in height. You can really see it right here. I thought that was actually really cool. The dark stuff is no good, Riv. The dark stuff and the super, super, super light stuff is no good. You need this, well, sandy colored one. See all that? That's all the limestone crap. That's what these piles are. That's all the dookie. That's the bad stuff. But see this, like, kind of, well, like I said, the sandish colored stuff, the one that's like tan, that's the stuff you want. That's the good building material. Yeah, they'll be testing for all kinds of stuff in the soil, not just stuff that can be toxic, things like sulfates that can degrade concrete over time. Bingo. Yeah, I thought that was super freaking interesting, and Vex, that's why I went and asked her about it. I'm like, okay, I know you got to take core samples because you got to understand what they're building on. Why would they grind the limestone off? Because I didn't realize, like, I'm like, aren't rocks something that you want to build on? She goes, no. I'm like, oh, all right, that makes sense. Where else is this being built in relation? It's down the street from the VAB, Livid. The VAB is over there. I'm trying to find the shot. Yeah, it's not really a good picture. But, yeah. Yeah, see, they're also, looks like they're grading a new road right here. Interesting. I wonder if that's going to be another heavy road like that one. Because if it's a heavy road, well, we know that from the plans that they're planning to build 2 high bays right here. Similar to the wide bay down at Boca Chica, which is called High Bay 2 officially. That's what they called it in a plan for it the other day. Was this the same site that SpaceX was using to build Starship back in 2019? No, this is closer to the launch pads, Livid. Yeah. Yeah, see, they're gonna supposedly build 2 gigantic integration towers here and here. Like the wide bays at Boca, which we will check out in a second. But yeah, see the darker stuff and the super light stuff. Not the beige stuff. The beige stuff is what you want, which is very interesting to me. I thought that was really cool. What will be going up? 300,000 square foot Starship production facility, Kato. You can see the footprint of the building. Pretty crazy, right? The wide bay will always be the wide bay, and I will die on this hill. See, they started digging out where the supports are going to go. See all the things in the, all the little marks in the ground? You can kind of barely see them, but yeah, they're getting serious, for sure. Yeah, there you go. You can see the marks a little bit better. These are all the spots for the support. Those are some birds for this factory. This factory is going to be freaking huge, man. Not gigafactory big, but still pretty freaking big. Yeah, Beltfed, the pilings, yeah. Sorry, I forgot the word for whatever stupid reason. When does the weekend for Shuttle Skunk work? Sunday? Wait, I did one trade study with it yesterday, and I was like, nah, this isn't gonna work. It's not really gonna work. Integrating it would be like, okay, let me put it to you like this. I could do it. I know I can do it. It would take 6 months, but I can do it. Putting a stack together like that would be very, very difficult, unfortunately. So, I'm going to... Actually, the architecture that I'm going to switch to, we're still in I'm still in like trade studies, preliminary design review, stakeholder expectations. Basically, the part that comes before development in NASA's systems engineering notebook. I'm envisioning, and don't get me wrong, it's subject to change. I'm envisioning something like
Discovery, go at throttle up.
Something like when I had mission mode operating with Condor and Neptune. A heavy-duty booster and a super heavy booster with disposable upper stages but reusable first stages. And crew is able to launch on the smaller booster. So, think like, alright, hang on. Give me 1 second. Where's that cursed rocket photo? Hang on. Jesus. Something like that. Hey, Taven, 36-month resub. Oh my gosh, Tiny Tug. I played with the rocket design in KSP yesterday, and oh boy, you onto something. Core, we're gonna make something crazy. But yeah, look at that. Take a Saturn V's third stage and put it on top of Super Heavy. Yeah, that could be useful. Yeah, that could be useful. That would be pretty neat. Yeah, it's gonna go, and then the first stage will come back down and land, and then disposable second stage for now. For now, that's kind of where I'm at. But yeah. Anyway, let's see what else we got. That was pretty straightforward stuff. That booster that's being transported literally is already flown and landed on a drone ship. SLS has some stuff that they need to fix, and they're going to roll back soon. The Blue Origin TCAT stuff is pretty straightforward. Blue Origin's building a lot of tents out here at former Complex 11. See all those tents up there that they're building? They're doing something. Yeah, that picture of SLS is money in the bank. Money in the bank. And then, yeah, they're doing stuff to the SLF, too. They still have that mock-up shuttle right there. I want it. The tents have got to be Jarvis-related. Man, if they come up with something, dude. You know what, Thomas? Their second stage could look exactly like Starship. I frankly don't give a frick. I don't care. That would be really cool. Learning how to manufacture Starship in those tents. Shh. No tears, only dreams. All right. Anyway, with that being said, let's jump over to Boca Chica and see what's going on. Let's go right here. All right. Once again, this footage, just like the last one, is coming from NASA Spaceflight. Nick took these pictures. Nick and Sweeney's one of two full-time photographers down there. Make sure we go over and subscribe to NSF. Subscribing over there and supporting them allows me to do what I do here. Please do that so I can keep putting my crappy commentary over these. Please, that would be really good. I'd really appreciate it, duder. Yeah, Thomas, I know, right? Yeah, King, something like that. Pause at 124. Sure, Vasya, yeah, that's what you wanted me to see, right? It was time-stamped, but I brought it back to the start. Let's see. That is it. That is, in fact, a metal box. Yep. It is, in fact, metal. And you can tell because of the way it is. You're a metal box. No, I'm the man in the box. Is that a crew access arm? So this has been there for a little bit. I hadn't seen any updates with it in a little while. In terms of whether it's a crew access arm or not, I'm not 100% sure. It does bear a pretty damn hard resemblance to the crew access arm at 39A, right? But also, if you look at this closely, it seems to be attached to the side of a shipping container. And I think that being attached to the side of a shipping container, unless SpaceX was going to make a crew access arm out of a shipping container, I don't think that's what that is. It does look like it, though, for sure. Pretty sure it's just offices. Last time we saw chairs and tables inside. Possibly. So, yeah. I don't know, man. Maybe. Like, I wouldn't throw it past SpaceX to make a freaking crew access arm out of X shipping containers. Like, that sounds right. But I don't think that's that is the case in this particular scenario. And yes, they are freaking sick-looking offices, right? Yeah. That's a road grader. Caterpillar. Road grader. Colonist access arm. Wait, what? Earth mover. Yeah, maybe, Sordin. It's interesting. Nice. See, that's the new nose cone design where they just take long strips of steel to make the nose cone instead of like a bunch of pieces this way and a bunch of pieces this way. They make the pieces vertically and then they weld it together at the top. See that? That's crazy. I think they made those new bulkheads the same way. Someone say hot dog? Hot dog? I didn't say hot dog, did you? Please provide picture of a gosh dang hot dog. No turbo that time.
Do I look like I know what a JPEG is? I just want a picture of the goddamn hot dog.
Whoa! Alright, that's enough. Bless you. Thank you. Old cargo door prototype at the production site. Interesting. What is a nose cone but a tall bulkhead? It has to be more pointy. It's scarier that way. It has to be pointier. Oh, that's the thrust simulator. Okay. Yep. I just want a picture of a goddamn hot dog. Hey, Bobby, look at it. You won't believe what I'm standing in front of right now. Man, this thing is nice. Look at that. I'll tell you what, boy. I'll tell you what. Yeah. That's the thrust simulator to test dynamic compression loads on Starship. It basically pushes up on the bottom in a similar manner to how the Raptor engines will push up on the bottom. This thing was originally attached to, I'm not sure if that's the original one. It might be. But these were originally attached to the suborbital testing pads, pad A and B, that are at Boca Chica. Nice, Penta. Yeah, it might be Vickers. I don't know. That's crane parts. Telescoping crane parts. It's telescoping crane parts for a crane that looks exactly like that, Trouble. They delivered 3 more rams for the RVAC mounts today. Interesting. Paddy, the Irish pad. Right, yeah. Yeah, Pontius, that'd be a really nice pad if they made that, wouldn't it? Yeah, I think that would be the good one. You have to make sure it runs off spuds though. I mean, you can make rocket fuel with potatoes. That's totally doable. Yeah. Not very efficient, but it's doable. Any word on the FAA environmental report? 7 days till it's supposedly completed. We'll see. Rocket spuds. Right. Bronto Skylift. Oh! 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 Ooh. Wow. That's pretty neat. Oh, that's the bottom of Super Heavy Booster, and that's the kind of plate that holds all the rockets. Think of like a engine plate in KSP. Yeah, that's the Super Heavy equivalent of that. It is an engine plate, Penta. Yeah, that's exactly what it is. Do you think all the rapid progress with Starship infrastructure at the Cape has always been the plan? It's always been part of the plan, Admiral. It may have been expedited slightly by the programmatic assessment, maybe. But, yeah, that's always been the plan, pretty sure. Is that cast or milled? Milled. Yeah, see these box tubes. Yeah. See the darker pipes right there? Those are that's where that thrust simulator attaches to. That's at pad A, indicating that they're going to do some type of test on a Starship soon. If I had to guess, what do you guys think? 24? It's got to be 24, right? Yeah, it's billet, Shaw. Yeah, giant planetary five axis mill. I think it's called the planetary mill. I think. I could be wrong on that one. I'm probably wrong. That doesn't sound right. Yes, those mills are gigantic. Yep. Unless they roll out another test tank. All right, Panther. That's... Don't develop an orbital medium-duty rocket without you. 22 is out in the rocket garden. Oh, excuse me. Sorry about that. That's the Space News yawns. 22 is out in the rocket garden, Shaw, so it's junk. 23 scrapped. 21 is scrapped. 20 is sitting at pad B, so scrap. Damn. Look at that thing. Yeah. Lots of scrapping. SpaceX's design comes at you quick. Also, I want to point out that, guys, this isn't anything new. That's not anything new for SpaceX, to be 100% honest with you. Man, if you go look at Hawthorne, there's a parking lot that's outside of SpaceX's factory just to the east. And, man, I remember looking at that parking lot back 5-10 years ago on Google Earth, and it was literally full of Falcon 9 prototypes. Most of it have scrapped. There was a Falcon 1 in there, landing legs, grid fins, all kinds of stuff. You can see it all on the Google Earth timeline. There's stuff everywhere. So that SpaceX like making a lot of prototypes and then saying nah, whatever, and then making another one saying nah, whatever, and then making another one be like, okay, that's the one. That's nothing new. It's all out in the open this time around. That's all. Nice autocorrect, Pops. I wonder how long it'll take for SpaceX to get that money back. Dude, it's gonna take a lot, but you gotta spend money to make money. Elon personifies that phrase. Any money that guy makes, he throws right back into the company or social media applications nowadays. But hey, whatever. That's equity in a company, not his company, right? Oh, they took it off. Huh. Huh? Huh. 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 Huh? Interesting. Okay. Huh. Well, that was a long space news with a break in between. But yeah. There is still some other things, but we'll share them tomorrow. If you think about it, though, Twitter does really make up a huge portion of SpaceX's PR. You know what, Rivian? That's a very good point. Oh, wait a minute. No. We gotta mention this part. Okay, it's been 4 months, and I had to get on a boat, but I finally saw the tiny tug again. The tiny tug. Where is it? Where is it? Where is it? Dang it. I gotta find it. Said parking lot. Oh, there you go. Thomas, where is it? You gotta find it. We have to find it. Where is it? You know what I mean. Please hold. Your clock is on the wrong time. Yeah, I don't care. What is that vessel? It's a tugboat. It's a tugboat. Thomas, we need the footage. We need the right footage. What is the name of that vessel? The Yes-O-Matic? Rush Marine. It's called the Mamba. We need the right footage. In the meantime, okay, NASA's just speaking trash on Twitter. That's good. And here's what I wanted to show you. Oh my God. Nice, Thomas. Yeah. Where's this boat, Elroy? Sister ship Judy? Here. If that didn't make you laugh, here, how about this? What you're listening to is actually a simulation of what would happen if Ferrari wins at Imola this weekend. Italian fans will be like... Okay, that's enough. Here we go, give me. I can't do it. I can't watch that without cracking up. The content you deserve. Okay, I'm done. I played this last weekend when we were talking about it. I was actually crying and my girlfriend was not.